And if you're fixing 50 of these a week, you're not doing anything else. And they cost around $150 each. They would not sell me repair parts. I don't know what that's about, but we're also just getting them completely packed with sand. That's why all the sediment, we're kind of the end of the line. So we get all the sediment in our canal section that we're pumping out of. And then our solenoids were just getting completely stuck. Here's a picture of one I took off from the beginning of the machine compared to the end of the machine. Repairing these valves takes 5 to 30 minutes each. There's electrical connection, there's a water connection, obviously. You need at least 3 tools if you're going up there. Better hope you don't drop them. It's a harsh work environment. There's not really a platform to work up there, so I'm kind of carrying everything you need. It could be hot during the summer. It could be wet if you're fixing a leak. Using a ladder in soil is not the greatest, especially when you're fixing something, because you know that soil's probably muddy. But this just seemed, again, unsustainable. It's too expensive. There's no easy repairs. I would end up doing it in batches. I wouldn't bother fixing them up there. I would just swap it with one I already had repaired, take everything in the lab and fix them later. But still, I mean, that's taking 2 hours before every irrigation. You don't want to be doing that 2 times a week. So part of the way we solved this is we revisited filtration. We've been working on filtration for 10 years, but now we have a greater need. It's not just messing with my time. It's actually just wrecking equipment. There's a price tag associated. We decided to stop using our pond, which is kind of bittersweet. The pond added flexibility, but it also added too much sediment. It wasn't worth pumping sludge in our canal and then cleaning it out all day. We decided for a while to sacrifice our span 7, which is the last overhang section. We have arching pipes, and then our last overhang kind of arches up. So all the trash kind of tends to go there and settle. We just plan to remove the variable rate equipment from the section because the valves seem to be the main problem. Just let the trash flow through this section, and it was kind of just a buffer zone for a few years, which worked, but you're sacrificing usable research area under advanced technology to do this. And a surprise improvement was one day I just opened a box of new expensive valves and they had a new design. It actually reminds me of the Coors like wide mouth cans. So instead of like a valve with the spokes, and it has like a big lip and sticks and things like that pass through easier. Our new filtration solution happened to be a valley intake. After much complaining, we finally procured a new intake. It has a much finer mesh size that doesn't allow anything through, and it has other perks too, like it actually self-cleans. It has a pressurized jet that will knock the trash away, and it has a traveling dam to help manage our water level. And in our first irrigation, we found out it will also scrub our canal. I'll occasionally use it to push all the sand out of our canal. So 10 years later, we've been doing work out there for 10 years, trying to make it manageable. I feel like we started with the huge wild beast and somehow turned it into a nice field schedule. We have our 2-day-a-week field schedule that kind of is the prototype all of our researchers use now. Our water quality problem is still present, but it's manageable. I'm gonna say we had 10 clogs total last year. And that is way better than climbing a ladder and fixing 10 clogs every day. The biggest benefit was we get to spend time away from cleaning to focus on higher goals. Things I'm still working on is I'm learning the irrigation software now. My supervisor, Kelly Thorpe, used to do all the mapping and stuff, but he moved on, and now it's something I'm taking care of. The self-cleaning intake could be optimized better. It's still trash kind of clings to it. And I'm adjusting to new research objectives. I need to learn how to make this equipment usable to new scientists, new technology. So this was our latest success in 2023. We had a cotton experiment, supported 4 researchers. We did it with our 2-day irrigation schedule. We minimized our start time, coordinated with U of A staff. We didn't really have any debris enter our system. We maybe had 10 clogs all year. Span 7 was used again as valuable research space for Dr. Harriet. And everything performed as intended, and all our scheduled irrigations were complete with the help of Alvin. So thank you. You guys have any questions?
Yeah. Does what was your spacing on your rock roll, was it 30 or 38 or 40?
They're on 40 inches. That was a fun event too, is that machine did not come on 40 inches. So I got to climb the whole thing and boom, move goosenecks. Our research has always been kind of fixed on 40 inches. All of our tractors and all of our equipment are set up that way. So I would be interested, but no, I've not personally done or see that. Yes. Thank you. That's what I was trying to prove. Mm. Okay. I'll look that. I haven't heard of that. I'll look that up. We have tried weirs before, and they do just get buried by sand. What's that? Yeah. Oh, sorry. Okay. Your question was about using a V-shaped weir. Sorry, he wanted me to repeat the question.
This for people by Zoom.
Good.
Thank you.
Mhm.
So our next speaker is Mike Bloomfield from NativeM. He moved to a higher position, so I don't know the title exactly, but he has been helping us with all our experiment related to pressurized drip. And this talk today is with the title Effective Maintenance for Drip Systems. And he has John with him who would talk about his own experience with the system.
Thank you. Yeah, my name is Mike Bloomfield. I work for NativeM. I'll introduce myself a little bit. I guess I'm a 5th generation farmer rancher in Arizona. I spent all my life here working primarily in agriculture and irrigation. So I'm excited to have John Summers here with me. So I'll go through some slides really quick, and then John Summers and I will talk together about some of his experiences with our systems. First, a little bit about NativeM. NativeM is a company that was started by farmers in the Negev Desert in Israel. It started out of necessity. As you can imagine, the Negev Desert in Israel has very, very little water, kind of in a very similar way to Arizona, no rainfall, and yet they needed to be able to grow crops to support and help take care of themselves. And so needing to conserve as much water as they can. And so they invented drip irrigation. And today we're a precision agriculture leader and the largest global irrigation company. And we're happy to be in that position, be able to say that we're helping people around the world solve really big problems of water conservancy and making sure that we can grow more with less of our resources. We're in a situation today where we're never going to get more resources. So all we're going to end up with as farmers to use is less resources. That's not going to change. We're going to end up with less water in the future, less arable land as cities encroach and as climate changes and less land becomes less arable, and our climate only becomes less stable as time goes on. So figuring out how to deal with all of that as farmers, right? This is our challenge. And not only do we end up having less of all these different things, we end up with a whole lot more need to grow food. A lot more people, a lot more mouths to feed, and the problem just compounds, right? And so what we end up needing to do is being able to give stability to ourselves as growers by taking more control. With precision irrigation, this is how we do that. So that we can grow higher, better yields with less water, less fertilizers, and other resources like labor, energy. And our systems allow people to grow any crop, any topography, any climate, any soil, pretty much anywhere in the world. Very good. But everything in the world requires maintenance. If you want to have good teeth, then it requires some daily maintenance. You got to clean yourself, right? Bodies require maintenance. You got to eat good, healthy food. All of the things we like to play in and work in, right? Our systems, our pools, they all require maintenance. Our sports fields, we like them to look nice. We like to drive cars and trucks. It gets us around, takes maintenance. Our heavy equipment, our tractors, right? Everything we do, it always takes maintenance. So maintenance isn't new. But let's talk a little bit about maintenance for your drip irrigation system. Really, on any irrigation system, all maintenance begins with design. If you have a poor design, it's just going to compound and make everything a whole lot more difficult. And so making sure that your system matches your topography, where you are, the soil that you have, what kind of soil it is, what is your infiltration rate, what is your soil makeup, what is your water source? Do you have well water? Do you have surface water? It's important to do a test and see how many total dissolved solids are inside of that water. What are the considerations that you're going to need to take to make sure that everything that you're doing inside of your system as it's being designed is designed correctly in order to make sure that you have the right filtration, that you have all the right things in place in order to help you have a successful system to begin with. How many gallons per minute of flow of water do you have available for you to use? Your whole system ends up needing to be designed around all of these things. And a good design ends up being one of the most key considerations to your maintenance program. And so all of these, different things for you to consider, and it's part of that design. Your water source, your filtration, your emission device, really, really heavy total dissolved solids or different things may determine how the emission device that you're capable of using or what you believe you're going to be able to use without plugging it, right? And then also the runtime, right? What do your deliveries look like? Do you need to end up putting in a pond to buffer that, like Matt was talking about? Do you end up needing to do different things to make sure that your system, that you're able to apply the amount of water that you need to apply to your crop in the right amount of time? It's system performance, right? So any system performance, what we end up talking about is distribution uniformity, making sure that all of the field gets the same amount of water at the same rate. And there's a massive difference between operating at 85% distribution uniformity versus 95% uniformity. Most of our systems trying to achieve 95% or higher. But if over time you're not maintaining your system and it drops down to an 85% uniformity instead, there's a massive difference in that system and in how productive and profitable your system is going to be for you. One, you're going to increase your runtime because you have to run longer, and you're going to end up using more water. You're going to end up increasing your nitrogen sources or all your other fertilizers, any fertilizer you're putting out there, because it's not as efficient. And so your sustainability ends up going down, as well as your ROI. And so low pressures, these are some of the reasons and issues that you can end up having, causing you to operate outside of your distribution uniformity. You got low pressures, larger sets can cause your distribution uniform to go down. And ultimately you end up with that 10% difference between 95 and 85%. It sounds like it's only 10%, but it actually ends up being a 20% difference in the efficiency of your system. And so it's important to be able to do some maintenance. An ounce of prevention is worth a pound of cure, right? It's great thing to think about. So at the beginning of the year, there's always some startup maintenance. Before you begin your system, you want to make sure that you go through and you can check a big checklist and make sure that you're doing some different things, the in-season maintenance, some year-end maintenance. And if you're in a place where you're going to have some freezing issues, which not really that much here, some winterization to consider and make sure that nothing's going to break if water freezes. So you have all these different components that maintenance is required on all of them. Your filtration, air vents, main lines, sub mains, and your control valves in line, drip lines. All of these things require maintenance. Your primary filtration, you should look at it at startup, during the season, the end of the season. Winterization, right? You don't want to be holding water inside of there. At the beginning of the season, you're going to make sure that you open that up, crack it open, see what's going on, make sure that your sand levels are correct. You don't have a layer of cake on the top of sand and silt sediment that's built up, and that everything is ready and ready to work for you and provide the protection that it's designed to protect for your system. During the season, it's important to make sure you do the same thing. Crack that open, check out, see what's going on inside of your filter. Make sure that it's working efficiently. Make sure that your pressure differentials are accurate, that it's getting a good flush. You end up with a heavy sediment load inside of there, and it really decreases the performance of your system. At the end of the season, same thing. It's important to check your sand levels again, add sand if you need to, and winterize it. You can end up with all kinds of different gunk and crap inside of there, and so it's important to make sure that we're doing these things to make sure that our systems are working well. So pressure relief valves, it's really important. It's a very important system on there. You want to fit your pressure spike for some reason, and that's not working. It can cause some big problems. And so it's important to make sure that it's set correctly, that it is functioning, that it does work, so that you protect your system with it and that it's actually going to be doing what it's designed to be doing. Your air vents are also a critical part of your system. If you don't have your air vents functioning and working, if the ball valve and that Waterman style gets stuck, or for whatever reason it's leaking or it's not opening when it needs to, you can get into all kinds of crazy situations where you might suck sand out of your filters and send it all through your drip line. You can cavitate lines. You can cause all kinds of big problems with your irrigation system. And beyond that, you end up with, if your air vents aren't working and they're not releasing air continuously, you end up building up air pockets inside of your pipes, which effectively decreases the inside diameter of your pipe, meaning that your pump now has to work harder because you've effectively just said, instead of a 10-inch pipe, now you have a 6-inch pipe or a 4-inch pipe, and it's trying to push all of that water through that part. Apart from the fact that it can be dangerous, you can build up enough pressure there that you can cause an explosion. So it's important to make sure that we do all these kinds of things during season. You can see the little nozzle right there. Ours make it really easy. If it's leaking or it's dripping, you can turn that up. You can put a little teaspoon of bleach inside of there. Come back the next morning, it'll have cleaned up anything that's caused any problems. Just normal liquid household bleach, right? It'll have cleaned up everything. Turn it back down so that we don't get debris and everything else building up inside of there. And then also, again, considerations for winterization. Here's a nice example of what some things can end up occurring. You want to make sure that you don't get things like that, right? So it's important to be out there and check on your field, look at things, make sure that everything's working the way it's supposed to, that everything is functioning correctly, and you don't end up with problems that are going to cause you headaches down the road. Again, all your pipelines inside of there, your main lines, your sub lines, need some maintenance at startup. It's important at startup you get a good flush through the system, make sure that any debris or anything that may have collected inside of there gets flushed out, so that it doesn't end up in your drip lines. So open your flush valves, get some good maintenance going on, and make sure that your system's all ready to go for the year. Your hydraulic valves in the field, you want to make sure that they're working, that they're regulating at the pressures that you want to. You want to make sure that, you know, somebody hasn't come around and a coyote hasn't chewed on some of your drip line, that 1/4-inch line that's in there and messed it up, or maybe you got an irrigator that was trying to experiment or discover or understand how something worked and they changed something, or maybe just some passerby decided to vandalize your control valve. It happens a lot. So it's important just to make sure that everything's working. Use your gauges on each side of the valve, make sure it's regulating how it's supposed to. During startup also, it may be important. There's a finger valve inside of where the water comes in, and it kind of, so that it cleans up any of the debris and make sure that you don't get debris inside of all the hydraulic system on that control valve. It's important to check those, clean them, and put them back in. Make sure that there's no sediments built up on side of the diaphragm. The diaphragm's not broken, cracked, ripped, so that it's working how it's supposed to. At the end of the season, it's during the middle of the season, at startup and at the end of the season is really important times to be doing these kinds of things. And it's a pain in the butt in the middle of the season when something stops working and it's 120 degrees outside and your crop is suffering and your valve, you're out there trying to fix a valve to make sure that it's watering how you want it to. In that pilot valve, it's important to make sure that pilot valve doesn't get debris and different things inside of it too. So this is just an example inside of that pilot valve, some debris that can build up causes it to stop working. And then obviously on your drip lines, effective maintenance is important on your drip lines. Regular flushing program during season. At the beginning of your season, you want to get a nice good flush, make sure that everything's all set and ready to go. In the middle of the season, after, you know, every so many irrigations, it's really important to open it up and flush. And when you flush, it's really a smart, wise tool to think about. When a lot of times our irrigators, they'll say, hey, we're going to flush, and they open it up, and when you first open it up, you're going to have some clear water, and then it's going to get dirty, and then everybody thinks that's the prime time to close it up because now it went clean again. The reality is that all you did was just flush everything that's kind of collected there at the end. Now you need enough time and flushing velocity to make sure that it cleans the whole drip line. And so if you just keep it open for a little bit longer, eventually what you'll see is it'll get dirty again. And then when it clears up, now it's time to close it because now you've cleaned out that entire drip line. Now you make sure that you flush it all out and everything that was inside there that may have built up on the emitter filters, that it's all clean and out of the system. During the middle of the season, also sometimes we end up needing to put, if you get some plugging, you notice by your meters that it's not running as effectively as it should be, as design is, then a common tool that we use is HP50. So you can put in there and flush your system with it, and it'll decalcify, it'll clean up the drip line emitters. You can get full flow going through your system again. Clean it all out and make it work. It's important to do that, usually at the beginning of the season, end of the season, maybe 2-3 times a year. A lot of guys end up doing to make sure that it's good. Another thing to think about, and maybe we'll talk more about this with John, but often, if you're in a crop that's a long season crop like alfalfa, and you want to make sure that you don't get root infiltration into your emitters. And so you can use a product called trifluralin. It's an herbicide, right? And it doesn't travel through the soil very far. So you plug that through and it's going to create a little zone around your drip line where the roots won't go through and into that zone and won't get into your drip line, causing any problems. So doing that every so often is also an important maintenance consideration to make sure that you prevent root intrusion. Root intrusion is a big problem that you don't want to end up having to deal with. And just a quick talk about what happens if we don't do maintenance, right? That's when your system performance ends up going down. It's not working how it's supposed to. Your system uniformity goes down. You're going to be watering more in certain places and less in other places due to plugging or different problems. Your distribution uniformity is no good. That ultimately ends up affecting your yields and making it so that you're not achieving the maximum yield that you can with your system, which decreases your revenue and your total net profit. So maintenance, while it's important to do some maintenance and make sure that you're doing all of these things, oftentimes we look at it like, man, I'm doing my maintenance. at the end of the day, that ounce of prevention and making sure that your system is working prevents a lot of headaches during season. And a system, when properly maintained, can last 30 years. It's a couple weeks ago, we were on a system that's right here. Howard Wirtz has systems. They were very good at doing their maintenance, and they have our same typhoon drip line that's been in the ground for 30 years because they do a good job of their maintenance and make sure that it's well taken care of. And he's not alone. There's lots of other people that do the same thing and that achieve really long system life, not needing to read tape. And that ends up saving you a lot of money and making sure that system continues to work for a long time. It makes it a good investment. Anyways, so I want to stop talking and we'll have some conversation here with John Summers. I'll let him introduce himself. Why don't you come up here, John?
Wish you'd talk longer, Mike.
You want me to talk longer? Nobody wants to listen to me.
I'm John Summers. Unfortunately, I'm not prematurely gray. Have been involved in drip irrigation for a number of years, in some success stories and in some failures along the way. We were some of the first experimenters in the San Joaquin Valley of California with subsurface drip on processing tomatoes in the mid 1980s. And we thought we had a huge success story, that we had typical processing tomato yields back in that time frame were somewhere in the upper 20s, 26, 27 ton per acre. And in our first year with subsurface drip and processing tomatoes, we were between 38 and 40 ton per acre, and thought we'd hit an absolute home run. We got the machines in the field and sent the first loads to the cannery, and the solids were so low in the tomatoes that we had pumped the tomatoes and pushed the tomatoes with the N, and you know, where solids are vitally important in a processing tomato, we had reduced the solids so much in the drip plots that we ground a 600 load a day tomato cannery to a halt. And the impact of that was the following year, tomato canneries had a clause in their contracts that prohibited drip irrigated tomatoes. And the research continued at the university level in California, and they figured out the things that we were unable to figure out, things like deficit irrigation at the tail end of the growing cycle, and potassium fertility, and ways to up the solids in the tomatoes. And I think today it's probably somewhere well north of 95% of processing tomato acreage in California is on drip, both subsurface and surface drip. So I don't, I've been involved in farm development and management in California and Arizona, and quite a bit of consulting work in Northern Africa. I don't see drip as a religion. We managed a lot of pivot operations in Northern Africa. There are places that subsurface drip fits as a water management tool. And in my opinion, where it fits extremely well. The benefits can be huge. It requires a different mindset. It requires a different management for sure. I've seen where farmers have tried a small plot on a 2,000 acre farm, have tried a 40 acre plot of drip, and it failed. And the only reason why it failed is that the irrigation foreman and the staff on the farm viewed the drip as interfering with the way they had always done things. And so, I mean, it takes a whole different mindset to manage. Following up a little on what Mike said, to me, in my mind, maintenance, just like he said, it goes back to design. And I think that ideally, if you're starting from scratch, you need to design a drip system kind of like from both ends to the center. That drip tape selection should be selected based on what the infiltration rates are of the soils and what the cropping pattern is going to be on those soils. And I think I read some data where they suggest that drip tape selection should be based on water delivery capabilities. I would strongly disagree with that. Block size should be based on water delivery capabilities. And on the other side, the other bookend to me is filtration. is, unless you're really intimately familiar with the water quality in the area where you're installing the drip, it requires good water testing, and you're concerned about, well water and surface delivery water are two different animals, but you're concerned about organic load. You're concerned about suspended solids, especially in the surface water delivery scenario, and the organic load as well in surface water. With groundwater delivery, you're concerned about chemical issues. You're concerned about hardness of the water and fertilizer precipitates. But all of that has to be taken into consideration to design the system correctly. And then back to the maintenance aspects that Mike talked about, you have to have a system that's capable of providing flushing velocities. And I see a lot of systems that really aren't. And, you're ideally in your distribution network and in your headers and everything, you should be able to get up around 5-6 feet per second as a flushing velocity in the PVC pipe. And I read stuff that says in my mind, like 1.6, 1.7 feet per second is more ideal in the drip tape itself. And how you achieve that, you have to have the delivery capabilities. It impacts block size a bit. It certainly impacts if you have flush manifold pipe sizing. But I think it's critical. Even if you have a failure, that if you have the flushing capabilities, you often can fix the failure. But if you don't have those flushing capabilities, it's really, really difficult. It's easy to get in a problem, and it's very, very difficult. You have very few tools to fix that problem. And I'm hoping for quite a few questions here this morning. One of the main considerations in subsurface drip is gopher pressure. Here in the Southwest, primarily gopher. Other places have voles and other rodents, prairie dogs, and I have very, very little knowledge outside of the Southwest and Northern Africa. To me, one of the biggest tools that you have is that a window, if you can decide that a field or group of fields is going into subsurface drip, is to have a spring, summer window when you have quite a bit of gopher activity. In a lot of Arizona, there's not much winter gopher activity, a bit more in Imperial Valley. It typically doesn't get very cold in Imperial Valley, but to be able to do heavy tillage, deep tillage, and then work that field back down flat with a float or triplane, and then if you have gopher pressure, when the mounds start to appear in that field that's flat, is we've typically used there's 3 or 4 different manufacturers, but a machine that makes the artificial tunnel and deposits strychnine bait. You need to have pretty decent field moisture for the tunnel, depending on soil type, but for the tunnel to remain open. And what we do is just crisscross those areas of the field. Just typically it's in certain parts of the field that have that kind of gopher pressure, and then float the old mounds back down flat again, and wait and see where you get new pressure again a second time, and keep treating it with the gopher getter. There's 3 or 4 different manufacturers of the machine, because the more you can do before you put the subsurface drip tape in, the better off you are. I mean, hugely so. A serious gopher infestation in an established subsurface drip field is a huge problem, a costly problem to try to take care of. Once you've put the subsurface drip in, there's repellents. Mike could talk better about the repellents than me. I've never been a real fan of the repellents, because although for some time frame it's preventing drip tape damage, it's not reducing the population of the gophers in the field at all. And we've found that where it's legal to use, and the regulations are different in California and in Arizona, but it's legal in both states, just under different regulations. The aluminum phosphide tablets are probably the best approach once you have gopher pressure in a established drip field. The carbon monoxide generators or the CO2 generators, effective, but pretty labor intensive. Trapping, again, the effectiveness of trapping is you get the satisfaction of seeing the dead gopher in the trap, but it's real labor intensive, real expensive from a labor standpoint. The machine that applies the propane and oxygen and ignites it and blows them up, it's fun to use at first. And after you fought gophers quite a bit, there's certainly a bit of satisfaction in seeing the gophers scramble out of the hole on fire. But it again, it's real labor intensive. It damages drip tape where you use it in the field. We used it in Imperial Valley some, on some flood irrigated ground where the gophers end up to escape the flood irrigation. The gophers end up pretty high population long concrete ditches, and you know, if the right amount of the oxygen and propane and will work, it really works a lot better if you put about 3 times that much in the burrow, and it will collapse concrete ditch in an amazing fashion. Applying it to gopher holes behind the concrete ditch. Mike mentioned root intrusion. You know, it depends on the crop, how serious an issue it can be. In a crop like alfalfa, it can be an issue, but if the drip system is functioning correctly, it really isn't that big an issue. We always do it preventively. We're putting on, I think, 6 ounces of trifluralin, and it varies who has a registration for drip for a trifluralin product, but 3 times a year typically. Where it can be a real problem is a tap rooted crop where you have an intentional dry down. Cotton fits into that scenario. I was talking to some guys who are growing sunflowers, again, that on drip, berry drip, same scenario, that you have an intentional dry down cycle, is that it's pretty critical to have the trifluralin application ahead of time, keep the root intrusion out of the drip tape. Well, yeah.
So, I mean, yeah, there's lots of different considerations. I have a couple of different things that we will talk about, unless you guys have some questions. If you guys have questions or concerns or thoughts about drip irrigation and maintenance and what that is, we'd love to answer some of those questions. If not, then we got a couple more things I'd like to talk about. Go ahead.
Just wanted to mention, if we have questions with the people at Zoom, it's better that they take the microphone to them and then wait until you will respond. Okay. Anyone has a question before we move to the next? Give me one.
We can probably do it without the microphone.
No, for Zoom. Yeah. There you go.
You know, whether it's
Oh.
salt mitigation and salt movement, really, Rick. I mean, there's products that claim miraculous results with salt. I mean, it's a leaching issue. It's a placement issue. In just like with any type of irrigation, if you've got high quality water and you've got saline soils, you have a future. You can make it work. If you have saline sodic soils and you have poor quality water, it's a difficult road to hoe, no matter what you're doing. But in a crop, we grew a number of crops, some specialty crops with pretty reduced salt tolerance, and a crop like alfalfa with higher salt tolerance on like 2,000 part water, but some real well-drained soils. And in the alfalfa and cotton a bit too, you wanted to see it white on the top, that you wanted from that drip tape, you wanted to push downward and outward and up, and germination being the only exception of that. And you would panic in these particular conditions. If you got 1/4 of an inch of rain or less, no worries. If you got an inch of monsoon rain or more, no worries. But if you got somewhere between 1/2 and 3/4 of an inch of rain, you need to get water running on those blocks as fast as you could, because it actually pushed the salts that had accumulated at the surface right into the ridge zone. But it's just movement. You know, I mean, I haven't learned any other. You know, I mean, you can help some in certain conditions with continual sulfuric acid application if you've got decent free lime levels in the soil, but still, it's movement. Where where you put it, where it ends up going. How do you keep it from out of the root zone as well as you can?
Another thing that we often tell everybody is, I mean, just like he mentioned, there's a leaching fraction. Sometimes it requires putting a little bit more water than maybe ET is saying, in order to make sure that you put enough water out there to leach out and move those salts through the soil. I mean, with drip irrigation, right, we're depending a lot on the capillary action of the soils, and so that water moves. And as it moves, it also pushes everything with it, right? So it's pushing soil salts to the outside edge, it's pushing it up and it's pushing it down, and managing that water profile and making sure that you're pushing the salts where you want them to end up being. And a lot of that ends up coming in design. If your system wasn't designed well, or you didn't take into consideration the infiltration rate of your soils, and it wasn't designed for you and for your specific soils, then it ends up becoming a harder problem to manage. But at the end of the day, it's just management, right? It's understanding what water you have, what salinity exists, and how to manage that water and make sure that it moves through the soil the way that you want to. Another consideration we always tell people is, if you have access to your flood irrigation water, there's no reason to take out your canals. Different timings. At the beginning of the season, at the end of the season, sometimes during the winter, you may have access to a little extra water. And putting some flood water out onto your field to leach down those salts. It has a myriad of good uses, right? It helps with the salts. It also helps with your gopher problems. And can help be a valuable tool in your pocket. I'm not a big proponent of a farmer getting rid of any tools. We have a lot of tools, and I think that each tool is to be used the way that it's meant to be used. And the more tools you have in your tool belt, the more effective you're likely to be. Were there any other questions before? Maybe I ask a couple different things. Yeah. Already. So the question for the Zoom users, right? He's asking if it's a common practice to use sulfuric or N-furic acid as part of your maintenance program. John, you wanted to answer.
If you have places with very high pH water and you're concerned about chemical precipitates, then sulfuric acid is probably a pretty good option. That on crops with relatively low nitrogen requirements, or pretty specific time windows when nitrogen application has to happen, it's a little tough with N-furic. I mean, N-furic fits in some places. If what you're after is buffering, it's an extremely expensive product to buffer with, I mean, so it fits in a role. We often use N-furic as a flush behind an application of something, but with real high pH water and correspondingly high bicarbonates, that the continuous sulfuric acid buffering is probably a good thing. With groundwater as part of that whole design thing, water testing at the beginning, I would certainly, if you suspect that you've got, well, even if you don't, but I mean, high bicarbonates is a titration, have the lab do a titration to see how much sulfuric acid it would take to bring the pH down. We've kind of gone through several generations. When I was in California, we were doing a lot of chlorine, both shock chlorine and continuous chlorine application. There were even guys who were, as a custom service, providing gas chlorination, which was less expensive and worked real well. It really needed to be managed by a custom outfit, typically on a medium or smaller size operation, dangerous to work with. Here in Arizona, I think that we've all kind of shifted away from the chlorine treatments and have gone with the hydrogen peroxide solutions. They're effective. They're pretty safe to deal with. In my mind, with surface water delivery, where we get organic problems, that they're actually more effective than the chlorine was. And we do the same thing, both shock treatments with the hydrogen peroxide solutions and continuous, also depending on the situation. The one thing that it's costly, but if it makes sense to people, the one thing I would suggest most of the time with the surface water delivery is a settling basin if it's possible to do it. You know, I mean, these districts in central Arizona here that had delivered a combination of CAP water and well water are all delivering pretty much all groundwater now, but through the same distribution systems, and the organic contaminant problems really are just as bad as when it was CAP water, and the settling basins really, really help. I am, for reasons that I can't defend very well.
Let me repeat the question real quick. He wants to know our preference on types of filter stations, whether it's San Media or some other type.
I like the San Media filter stations. It's easy to train your crew how to operate them. They're relatively bulletproof, especially if you have adequate filtration or a little bit extra filtration for the water conditions. I think it's defensible with surface water. I'm not particularly a screen filter fan at all. That screen filters tend to work all right with groundwater, but anywhere you have both organic contaminants and you have sand or silt particles, with the screen filter, the organic filament lays over the hole in the screen and the sand particle sticks right on top of it. The disc filters are good. And I've operated the disc filters. I have more of a challenge teaching the on the ground team to deal with the disc filters rather than the San Media filters. The footprint of the San Media filters, I guess it still would matter in Salinas Valley or Yuma, you know, but I mean, in central Arizona here, we've all got more land than water. So I mean, the footprint size is not really very important in my mind. But I'm a San Media filter guy at the end of the day.
I would mimic that. I mean, you know, we do more San Media filters than anything else in Arizona and really all throughout here. A lot of times if you have very clean water and groundwater source or something that's very clean, high quality water, you can get away with a screen filter, right? The considerations being there, the screen filter is less expensive and is going to use less water backflush than a San Media, right? And so if those are your goals and your water is adequate to allow a screen filter, then it can work just fine. Maybe sometimes you put a sand separator before it if you have a heavy sand load coming from your well. But hands down, I mean, you know, a San Media filter is the most robust filter that there is, and works really well. If like I said, if the space is a consideration, right, then disc filters meet that requirement. They also use less water to backflush. It's a different type of maintenance and a different way of taking care of it. And you know, just making sure that you understand that and you're teaching people how to understand it and use it in an effective way. But you can, I mean, you'll get a lot of filtration capacity in a very small footprint with a disc filter. But I still prefer San Media.
And a bit of a disclaimer, I have absolutely no experience with any of the filtration issues, iron and associated with low pH water. I have a short prayer I say every night that before my career ends to actually get to farm with some lower pH water, but I have never never been able to see how that works.
Other questions from the audience back here in the back? That's a good question. So the question was if we've used the nano bubble, I think systems with our drip irrigation. You know, when it first came out, we did some trials. I don't know how effective the trials really were, and I can't really speak to the effectiveness of the trial. We ultimately, I know that Netafim ultimately didn't end up partnering with the company that we did some stuff with because we didn't see any large benefits from it. But you know, there may have been other considerations in that too. What I know is that we didn't see a whole lot of big benefits inside of the trials that we did.
I think, I would admit to maybe being a little bit lazy, not following up on some of that, whether it's the nano bubble creator or whether it's the Maisie installed on every drip line with an air vent to the surface. I think it could have some real benefits on heavier soils, poor drain soils. Haven't played with it enough. I think that a place where it'd be real helpful or is somewhere like in Imperial Valley where you've got tougher drainage conditions, and I think it really might make an impact, and would sure like to see work on that.
Not for sure. I mean, it's very interesting and we love seeing new technology. So we'll take one more question here. What do you do with the used tape? Well, if we lived in California, I could tell you that you pick it up when we have a recycling center in California, right? That'll take it. Often that used tape doesn't end up being effective to send to our recycling center in California, where we recycle and then put it right back into our product, right? But there are recycling centers that will take that product and use it. And there's different ways to get that picked up and taken where you can get it recycled and used rather than just letting it sit and pile up and be an eyesore. Any other questions? Okay.
I can't help there. Everything I've ever done to get rid of it is illegal.
At the end of the day, I just want to say that NetFM really cares about making sure that people are successful with our systems. And so we put in a lot of different places, checks to make sure that we're providing all the support necessary. We have Irrigation Academy where you can go. And if you're interested, we'd love to send you. We do it in NetFM and at our headquarters in Fresno. We have all kinds of resources on our website. We publish and print everything about all our design specs because we don't really think that anything is secret. And I mean, a lot of manufacturers out there will hide things. We don't. We really want you to have all the information that you need in order to be successful. There's an app for your valves. And if you guys are interested in that, it shows all the schematics and designs for all of the control valves that we have. If you ever have to make any repairs, you have to do anything, you can change your control valve or do whatever you need to and know that you are setting it up correctly. We have a tech support team that you can call in and get help with. If you ever have any issues in the field, it's 24/7 line, they answer it. Several different guys that man it, or it goes to their voicemail and they call back as soon as they can. And then we also have a team of people that live typically in your area and are happy to come out and work with you, help with you, and troubleshoot problems. And we always like partnering with people to help make sure that we get you the support and the resources that you need to be effective and have the success that you want with our system. So I'll end by saying that, and thank you for your time, and thank you, John, for coming to help me.
So I would like to thank Mike for his talk, and I would like to mention that NetFM, they are sponsoring our experiment here at Maricopa Agriculture Center. They provided lots of parts, and we consult with them all the time. It's a big experiment to compare flood to pressurized drip to center pivot. So thank you. And now we'll move to Syntec company. So we have Bob from Syntec. He will give a talk with the title Soil Moisture Monitoring for Smarter, More Effective Irrigation. You have a very nice sensor that we are using in our experiments. And here is Bob.
Good morning. My name is Bob Gills. I'm the North American Managing Director for Centec USA. And our main office from a sales and business standpoint is in Fresno. But our US warehouse where we supply all of our technology in North America is out of Benson, Arizona, 35 miles east of Tucson. And so but the interesting thing even with that is that we just started working with University of Arizona. We do a lot with universities across the country. Perhaps many of you are familiar with a program called TAPS, Testing Ag Performance Solutions, and that's with Kansas State, Colorado State, Oklahoma State, University of Nebraska, which was sort of the initiator of that whole project. And we're really happy to be down here with Dia and the team down here. It's an exciting opportunity, but the interesting thing, I will tell you, the theme of this whole session is maintenance of equipment. Well, I'm not going to talk about maintenance of equipment per se, but I'm going to talk about maintaining the right amount of water in your soil. See how I did that? And that's that. And we've talked today about, some of the folks about variable rate irrigation, precision irrigation, salt mitigation, and all of those tools, or all those issues are things that soil moisture probes can help you with. And it's interesting. We were at Valley last week with one of our partners, and we're talking about even in the state of Nebraska, where there are something on the order of 60,000 pivots installed, only 10% of them use soil moisture probes, 10 to 15%, let's say. And I'm curious, of all the growers here, how many use probes or for that matter, how many use probes, period? Anybody? How many do not that are irrigators here? Okay. How many of you have been happy with the use of those probes? It's been pretty good so far? Okay. On and off? Well, let me just get into who we are, how we use these probes and or how clients use these probes. And I'm not an agronomist, I'm not an engineer, and I didn't graduate college in 2015. I'm an old guy, but I've been around technology all my life. And this is a very straightforward, I hope, discussion about the business value of these devices, these probes and the associated telemetry and software. So what I want to talk about is how you collect good data about your soil profile, meaning the first 2, 3, 4 feet of your soil. Once you get that data, how do you interpret that data to better understand your soil and crop water dynamics, right? And then thirdly, how do you take that information and execute a strategy to match what your crop needs to get the best return on your water and your resources? So not to belabor this, because like I said, I'm not an agronomist, but just understanding, or sort of not understanding, but reviewing in your mind, because this is key to how you use the probes. The soil characteristics, when saturated, where the soil can't hold any more water at that point, and it's basically draining or running off at that condition. Secondly, field capacity, where it's essentially, if you will, the perfect situation. And thirdly, where you reach permanent wilting point. And this all, as you know, varies with the type of soil you have, what that number is. But those are the 3 kind of things that to keep in mind as we go through discussing what we're going to do today. By the way, I know I only have 15 minutes, and that old saying, if you want me to talk for 3 hours, give me 10 minutes to prepare. If you want me to talk for 15 minutes, give me 3 weeks to prepare. So hopefully I've got that down. There's 4 things that we sort of say are the tools for the job to accomplish what you want, and understanding your soil profile and how that can help you with your irrigation. The first is the probe. the Centec drill and drop probe to collect your soil moisture data. Now, this is this is a 2-foot probe here. And I think some of the folks here at U of A using 3, but mostly 4-foot probes. All depends on the crop and how deep your roots are and all that kind of related stuff. But the probe is the data collection unit, if you will, the IoT device, if that means anything to anybody. Collecting that data, the telemetry, our telemetry or anybody else's, depending on how you're doing that. In our case, our telemetry is going to, if you will, talk to the probe and tell that probe, collect data, please. And you set it for how often you want to do that. Typically, we see it's every 30 minutes. Collect the data, take it, and then send it to the cloud where our Irrimax software sits and takes that data and displays it in a way that makes sense to the grower or the agronomist or whoever might be mostly involved with this project. So those are your first 3 tools. And the last tool is your brain. Those are pretty much the 4 things you need to be effective. And I'll show you what we mean by that. So the first thing, if you're collecting soil moisture data, is you install the probe. Now, what we think is very important is that you install it and you don't disturb the soil profile, the true profile when you're installing. There are some situations where in order to install a probe, you install the probe and a slurry must be installed along with it to make sure that you have good contact with the soil and the probe. That's because of the type of the technology we use. I'm not going to get into it specifically, but it's the most popular in agriculture, and we are the inventors of that. In fact, our founder, Peter Buss, brought the type of technology, capacitance technology, to this market in 1991. We've been around that long. In fact, we ship about 15,000 probes a year worldwide, about 7,000 of them here in the US. So we figure we got 100,000 probes installed. So you've got that, you install that probe and you drop it in the ground and it's ready to collect data. And you put that probe essentially in the ideal place, in your field, which is where most common soil type and one representative of the way the field looks. So now that this is just a description of what that looks like when it's installed. You've programmed that, and I say programmed, it's basically a setup, say, I want this probe to read every 30 minutes. And I've got a 4-foot, if I have a 4-foot probe, I have 12 sensors. I have a sensor every 4 inches that's reading data. 3-foot probe, I have 9. And this 2-foot probe, as an example, has 6 sensors. There are little dots on it that you can tell, but that's the way they are. And this measures the soil water content around the probe, both horizontally and vertically, horizontal and vertical, right? And in this case, let's just say as an example, it's every 30 minutes. So that's data is taken, sent to the cloud every 30 minutes, generally speaking, depending on how you set it up. And then it's displayed. So now we're going to take the Irrimax software in our case, by the way, this could be another third party, display that collected data. And typically the way people look at it is on a stacked graph first and a sum graph below that. And I'll explain what that means. This guy right here, as I said, has 6 sensors. 1, 2, 3, 4, 5, 6 over 2 feet, every 4 inches. What this is displaying is exactly that. So this guy right here on the very, very top, the black line, that is essentially the plotted value of that top line's sensor in this case, let's say every 30 minutes. So you can tell because it'll look at the soil moisture content and it takes it as a percentage and says, you can see how that varies as time goes on. Well, you can pretty much clearly see where the irrigation event is when you get that big spike up on, what day is that? July 11th at noon or whatever that, 6 o'clock, 4 o'clock, whatever that might be, right? That's the big spike. That's where the irrigation event happened. And you can see as time goes on, that soil water content decreases over time. So that tells you at that first 4-inch level, how much water you have. Well, you can also see that at the 8-inch, the red line there, that the water got down to that level. At the 12-inch line, the water got down to that level. At 16 inches, however, you don't see the penetration. Maybe that's okay, maybe it's not, depending on where your roots might be, right? So essentially, that's how that's interpreted. And that graph shows you there, the first sensor is the first 4 inches, the second sensor is the 8-inch level, and so on and so forth. Now, the bottom graph here, the sum graph, is merely a compilation of the first 2 feet in this example of what the profile looks like. So on the top, we're showing it by percentage. On each graph on the bottom, that's the water level. So in 24 inches, it's reading that there's essentially 10.8 inches of water out of that 24-inch profile. That comes out to about 45%. If you took the average of that very first reading here on the start, that's about what that is. That's 45% total water. Okay, and that's, and by the way, there are different soil types that have, so depending on the soil type, you calibrate differently. This is more of a second level question that we can get into offline because I only got 15 minutes, but I'm happy to talk about it. All right. I have 2 minutes? Yeah. Are you serious? Yeah. Holy smokes. So this is the day, this is what you see essentially when you're going through this process. This is the sum graph that shows you how the water is taken up by the plant. And you can see that stair-stepping action gets narrower the further down you go, which means the plant is having a harder time pulling water out of the soil. Well, in essence, this is what this displays. We call this the drinking speed of the plant. As it slows down, that bottom line says that's where my stress is starting. And that's when I want to think about irrigation, my next irrigation, for irrigation planning. The top line is just the sort of the saturation level. We'll get into that later if you want to offline. We provide the tools for your brain, but believe me, I need them, is to look at how that's happening. So these little ovals you see are really our measurement of, say, hey, this is the root activity, and this is the amount of water that was taken up over the time length that happened. And these little blue carrots, if you will, are indications of the depth of the irrigation and how effective it was. So what does this mean? This is the key: reduce input costs, water, energy, labor, fertilizer, and increase your yields and have more consistency and higher quality. And last, here's an example. We were talking about cotton earlier. This is a customer of ours in Australia. Implemented the probes, used the software, saved 138 million gallons of water, 630 more bales of cotton, and additional income in the first year, 210,000 in US dollars. So there you go. I guess there's no time for questions, but hopefully you'll have some. Thanks.
So now our next speaker is from Valley Irrigation Company, and the title for his presentation is Center Pivot and Linear Systems.
How are you, Dia?
I'm good.
You don't want to try it? Dia's telling me he's afraid to say my last name, so we're gonna get him figured out here. It's just keep it on that. Okay. Okay. Good morning, everybody. My name is Steve. Are you ready, Dia? Here it goes. It's Korleski. So just so everybody knows, I'm from Northern Colorado. I am the Southwest Territory Manager for Valley Irrigation. So I cover everything basically from Colorado clear to California. Obviously, Arizona is part of that territory as well. I'm going to speak to you a little bit today about just the maintenance of mechanized irrigation from pivots to linears. And we'll go through some of our slides. It's not too in-depth, but it's in-depth enough to kind of keep those of you who do not have any type of mechanized irrigation quite yet maybe it's something that you're considering. These are just some talking points of when you do decide to make that purchase or you decide to make that initial investment. These are just some of the things that you're going to have to consider when you do have a pivot. And it's really going to be based on your dealership, your local dealership, us as a manufacturer, our distribution. Those are the types of things you want to always kind of consider. But the biggest one, if you do, and maybe you currently already do have a machine, maintenance is going to be the biggest thing to these. So we'll kind of get started here. Maybe. They're good. So at Valley has been the staple of irrigation since the early 50s. We are the largest pivot manufacturer in the US globally, actually. Valley is the top shelf of pivots that you'll ever find out there. And I know that we've got one out on your guys' research farm. So it's something that, you know, we are the strongest, longest lasting center pivot and linear in the industry. You see a lot of linears down here and you will see pivots. So it's whatever that field is going to be is what's going to work the best. So, and some of these maintenance points on these machines are going to be gearboxes, center drives, flotation as in tires, sprinklers and regulators. But the main thing that we always want to take in consideration whenever owning this type of machinery is the drivetrain, gearboxes, center drives. Without those, the machine isn't going to move. So it's, you know, there's a lot of hard times where, especially down here where it's super hot, these types of points to these machines are getting the most use out of them. So it's something that you want to take in consideration to where you guys down here are running them pretty much year round. So we'll kind of just start with gearboxes first. The great thing about Valley Irrigation is we make the whole machine right here in America. Everything's manufactured in the United States. You always want to kind of take that in consideration when looking at other manufacturers that we pride ourselves in USA made products. We're the only ones that actually make our gearbox in Valley, Nebraska. So these are great things to know, and knowing that we are always continuing to try to improve the products that we manufacture every day. Sound good? I did throw this up there. Probably going to have somebody tell me I'm wrong, but to me, I find it very valuable that the Valley gearbox, which if any of you own a center pivot or a linear out there, one of the things is that if there's one thing to fail, and we've got dealers in here, the one thing that fails the most are gearboxes. And so we pride on ourselves that our gearbox will outlast any other gearbox. Most other manufacturers source them from overseas. We do not. We keep ours right here in home in the United States, and we're proud of what we do. And I'll let you kind of just look that over real quick, but ours will outperform everybody else's, which makes us the leader in what we do. This was a great one that I pulled. They did an in-person grower interview of 25 growers with over 400 machines. And without even asking the question, without prompting it, everybody was mentioned gearbox by 50%. So you take that in consideration. For me, is if that gearbox is the most used component on that machine, we definitely want the best that we can have. So I'll go through here just through a couple of steps on why ours is the best and what we have to do to kind of maintain those gearboxes to give you the most longevity out of that gearbox as well. There again, too. Strongest, longest life. The other one is availability, quality, reliability, and durability. We're continuously trying to improve our gearbox. There's a few of my dealers in here today that, you know, they'll tell us whenever there's an issue or they see something that they don't like, we take it back. We have a group of people, product managers that continually are working on this, and engineers to making sure that we're giving you the best products out there. Here's just a small look into our plant in Valley, Nebraska. The one there with the start of shift, if you notice, that is just a continuous move. That's how we test our bowl gears and everything. That thing just runs 24/7. We want to make sure that we're going to give you the best out there. Any questions so far? Who owns pivots in the room? Linears? Oh, I know, I seen it. We seen you up there. We just need to change the brand. No, I'm kidding. Yes, see, that's even better. So here's another one of just more of constant testing. We're improving that performance. And it seems like I'm beating a dead horse here, guys, but the gearbox is everything. I used to work for the competitor. It was a throwaway gearbox. We just don't do that. We still manufacture all the parts and the pieces. You can tear these things apart and rebuild them on site. So that's something that most everybody else does not do. We pretty much just get rid of them at that point. So here's our housings. We do cast everything at a separate location from a different vendor. They bring them in, and then we have robots here. We take them, we machine them, we fine machine them, making sure that they're going to be to meet our specs in order to, when we put that out to the customer, that you guys get the best of what we have. Okay. And on changing the oil in these things, I was back there asking Rick a little bit ago. So we want to change those oil in there. We use the best oils out there that we can use. We try to change them about every year to every 2 years. And it's a gear oil, and it's something that you want to definitely maintain. And hopefully everybody knows that. And if you don't, I would definitely start doing that. Gearboxes are not cheap, and you don't get one, you get two per tower. So if you go 7 or 8 towers, that could be a costly expense. And something as simple as just changing the oil in these things is going to make it last a lifetime for as long as you own the machine. Okay. And there again, I was talking about the oil in them. That is a very, very important piece to that. Same thing with your motor center drive, which I'm going to talk to here in just a minute. Any questions so far? I could stand up here and dance and make people smile a little bit if I need to. Yes. Yes. Say that one more time, Dia. The actual gearbox itself? No. The only time you'd ever change a gearbox is if it's leaking or if it freezes up. But if you continue, it's like changing the oil in your car. If you drain the oil out of it and you put new oil in it, it just extends the lifetime of that gearbox. Does that make sense? Okay. They make different lubes and different oils for these things anymore today. There's even some outside third-party vendors that make stuff that, I mean, they'll guarantee the gearbox for as long as you have that oil in it. Now, that's on you to take that risk. But for us and for our warranties, we ask you that we use what we put in the gearbox. So, and probably the biggest thing for me, and I'll reiterate it one more time, is manufactured in the USA. That's huge. You get what you pay for. I'm getting to the point in my life where buying a pair of shoes, buying anything that you see out there, I always look for USA made products. We want to keep this in-house if we can. Okay. The motor center drive, that's another vital piece to this. The thing about the motor center drive for us at Valley is we offer, there's 5 different motor speeds that we do. We don't just put one motor speed on all the on a pivot itself on all of them. We try to go with the slowest to the fastest out towards the end. So that's something that we do differently. That's big for us, I guess. The motor center drive, there's another piece to that we do manufacture that ourselves. So outside of that, I mean, that's the other component to this piece is that motor center drive. Gearboxes, motor center drive in the middle. Everybody get that? Any questions? So the biggest benefits to us, shows 3 times, showing to last 3 times longer than our competitors. We got 40% higher torque rate on our drivetrain. The lowest power consumption available in a multitude of different speed applications. Having that multitude of speed applications is very beneficial, especially if you're going to do VRI. If you're going to start doing some of those other things that you want to add to your machine, these are things that we need to know and that we can customize that machine to your liking. So I know VRI is another one of those that you guys have, it sounds like, and we definitely want to take that into consideration. Flotation, tires. If anybody knows about tires, there's nothing worse than changing out a tire in the middle of summer. 8-foot tall corn. I don't know if anybody's ever done that yet. It's the most miserable job in the world. Besides that, a gearbox. So flotation is another one of those. You always want to check tire pressure. You always want to make sure that your tire's in good shape. That's another one of those that, you know, tires, are they getting any better? I think they're all about the same, but we do source those from an outside source. I feel that we have a very good tire out there for what we have, but it's something you definitely want to keep an eye on. There is another product out there that we have that I didn't have the slide up there quite yet. We are going to market again this year in a with not a lot of growers out there, but it is something that we are pushing a little bit. So we have something that we're using is machine diagnostics. And machine diagnostics is something that we add to this pivot. You kind of notice up there in the corner. So each tower would have its own separate tower box. And machine diagnostics is going to be able to tell us what's wrong with the machine at any time. Go ahead. So you can do tubeless or you can do tubed. Most of the growers that we normally see, and maybe one of my dealers would tell me I'm crazy, but most of the time we will sell them with tubes. A little bit more longevity. Oh my God, sorry about that. But yes, we do. You betcha. But the other one is machine diagnostics. And so with machine diagnostics, we can tell whether that drivetrain or the center drive is starting to overheat or starting to slow down, or we're getting a larger amp load on that tower. You'll get a notification on your device, on your cell phone. And what we can do is it helps eliminate or helps reduce that downtime to where we can actually send a service guy out to go fix it, or you yourself as a customer can go out there and go look and see what's going on with it. With that being said, we are hopefully this year is the year. We did try it last year a little bit. They did do some redesigning on it, but it's tire pressure is the other one. Kind of like your tire pressure on your car. We're doing the same thing for center pivots. And what we did try last year, it did work. One thing Valley will do, they continuously test the heck out of stuff before we bring it to market. So it's going to come out to market again this year in a smaller group of people, but I would almost suspect by next year we'll have tire pressure and we'll have the full gamut of what we offer with that particular product. So any questions about that? That's kind of an easy button for a lot of people. I mean, if you could see what's exactly going on with your machine at that time, that's nice to know. Now you talk about tubeless, then we got the airless tire. This is another one we've reintroduced this for us. This is a company called Galileo. We did source this from an outside company. So with the airless tire, that eliminates any flat tires at this point. Galileo is not specific just to Valley. They are going out there to the other competitors. But we are finding with our extensive testing that this is going to be the tire that we're going to kind of push through our network. It's something to just kind of take in consideration of what we use. I know there's some other new ones out there like Shark Wheel and some of those. We don't necessarily have those in what we're going to offer for this year, but this Galileo tire is something that we're pushing. We have sold quite a few of them so far. And what we've heard back from our customers is that they really do like them. Now, does that work here? I don't know. We don't have anything down here. Go ahead. Nope. I think it is. Yep. It's new for us. So last year we got our first ones. We've had a couple of different versions of it. Actually, I take that back. It's been a couple of years. And when we test them, we really test the heck out of them. But I can't tell you exactly what the rubber really is. So yeah, no, absolutely. But this is definitely something that we're pushing pretty hard. We've sold quite a few of them, like I said, so far. So we'll see where it takes us in the future. So any questions about that? Yes. Price difference between the two, that's considerably more. It is just due to the fact that it doesn't go flat. Yeah. I'm afraid to tell you, but it would probably almost double your price. But you know, you take a tube and a tire and your downtime, if these never go flat, I mean, that's kind of where you have to kind of weigh those options. So the other company, Shark Wheel, they're doing the same thing. They're a little bit less expensive. We find that the Galileo works better and it treads different. We'd like that a little bit more than what we were seeing in the Shark Wheel. So longevity with this compared to the other one is, this one is outperforming. Same rim. We have specific rims for Valley, so we have our own, but yeah, it will go on the competitive machine. That's what you're asking. Yes. You mix as in a normal tire and as long as they're the same. Yeah. We had, you know, there's been some issues and I can almost guarantee you some of our competitors take a 14,924. We have found even the same manufacturer, they might be off just a little bit. And that was just quality control from different manufacturers that we get our tires from. But I think that they've kind of fixed most of that. So good questions. Any other questions, guys? So this is the last part of my slide so far. Sorry. If you don't have a good sprinkler package and you're not servicing your sprinkler package, this pivot means nothing. Because if you don't get good water uniformity and if you're not paying attention to these things, you're just throwing water out there. And it's surprising year after year, as many dealer events as we go to, as many farmer events we go to, and you go down, you even talk to local farmers, and I could tell you stories until I'm blue in the face, but we've got growers out there that have had the same sprinkler package on for 25 years. And basically it's not giving you what you need. Nelson, Comet, Senator, there are 3 top ones that we use normally, and especially down here in Arizona. They're getting to, you're going to rely on your dealer and what they feel is going to be a better solution for what you're doing for a sprinkler package. The regulators, which let's see, that's the Nelson. The regulator, if you see the yellow with the black, that's Comet's regulator. Senator's is white and black, and then the Nelson one is blue. That regulator, there's a spring in there and there's a diaphragm. That it doesn't take but, you know, and I've asked a couple of my dealers locally, 2 years. I mean, and you're starting to, you know, you guys are running double to triple the hours what we would be in Nebraska. So you're burning through that pretty quick. That nozzle in that actual sprinkler device itself. And you were talking about garbage and I'm sure you unplugged a few nozzles. Yeah. And 9 times out of 10, I'd almost tell you that most people get a piece of baling wire and they take it through there and they jam it through the nozzle. Well, that nozzle is not the same nozzle now. You've just bored it into a completely different one. And most of our sprinkler manufacturers make something to clean the nozzle out. It's more of a plastic device and not a piece of, but yeah. Baling wire gets used for everything, I'm sure, right? But that is something that is don't do if you can help it. I didn't believe in it at first, and then you started reading reports and looking at other things. That's very detrimental to that sprinkler device. So if you have a pivot or a linear down here about every 2 years, you need to definitely dive into your dealer and have them test them. You can test the regulators to make sure that they're maintaining that 15 pound or whatever poundage that you put on that sprinkler package. But it's something that you definitely want to stay in front of. They run sprinkler package promotions all the time. If I was going to give you any maintenance thing out of this whole presentation, this is the number one that I would put. Because without this, the rest of it means nothing. And I would almost venture to guess that most everybody who owns that, any type of a mechanized irrigation would probably have to tell you that that's true belief. So this will give you your best uniformity all across the field. Would anybody disagree with that? Didn't think so. Questions? Yes.
We can apply maximum 0.5 should be okay, but the problem is it doesn't give us enough time for us to go inside the field for the big content. So in that situation, do we need to change only the nozzle, or do we have to change the farm to take care of the extra?
So talking about the regulator, you mean? Would you have to change your regulator and the nozzle? Is that what you've asked? Yep. No. No, your pump is already set up. You can run multiple sprinkler packages off the same pump and the same regulator. And it's however you design it, it's just going to be nozzle sizes at that point. Yep. Yep. Any other questions? I'm opening it up to questions because I've got 7 minutes left and I'd sure hate to leave here early. Yes. That's perfect. Yep. No, you're doing it absolutely the way you're supposed to. Changing out regulators? Yes. Most farmers, no. And the only reason is because cost. And they feel, well, what's another year? 10 years later, it's like, maybe I should have changed that out 2 years, 2 to 3 years. And like I said, I asked a couple of my dealers down here locally, depending on how many hours you get on that, because these guys, they reach out to these manufacturers, Senator Comet and Nelson. And I mean, these guys, they make exceptional products, but it only works as well as what you're utilizing it for. So, but this is the number one for me anyways, in my market and what I do. Sprinkler packages are number one. We could probably go to 50 farmers tomorrow, and I would almost guarantee you that most of them, this is the least looked at with a lot of guys. They want to make sure the machine's just running. So, yeah. Quality of water. Absolutely. You get a lot of sand, you've made that nozzle that much bigger. Sand, debris, and you were talking about a lot of weeds and a lot of stuff you're running through that machine. That just shortens the life of that device for sure. Yeah, absolutely. Any other questions? Dia? Now, hold on. You said you really like what? The Valley machine? I'm sorry, I had to say that out loud for my friend in the back. So yes, that's good to hear.
The number that we have our phone is different from the chart. Chart would say you would apply this what color. On the system, it's more like 4 or 5. That we follow the chart. Right?
So-
They have not done that.
Yes, it's something we definitely need to take a look at. The sprinkler chart is normally what you run off of. It's 100%. Yes, should be. Yes. I can't tell. So this particular company, Senator, does make one now that it is off. It is part of the device. I don't have a picture of it because it is new, but it screws off to the side. There's another thing that you can actually put at the gooseneck. It's called an excluder. You can put that. That's a little filter. Those aren't as fun to put in or try to keep clean because it's actually, you got to get up there and twist all that off. You can do that. I don't know any other filter out there. Rick, would you know of any other type of filter that you would use with the sprinkler head? That's really about it. You want to try to filter it before it even enters the machine. If you can, as much as you can anyways. So there's going to be fine. If it's small enough, we'll hopefully just release it. And I seen some of your pictures that you showed earlier of your valves and your VRI. You shouldn't be getting that much. We can hopefully try to eliminate that. So if you continue with that, let us know and we'll come out and definitely. Good. Good. I love it. Yes. Did you have any more? You're good. I'm done. You ain't going to get anything more out of me then. Thank you guys very much.
Since we have a little bit of time, I would really like to mention that this survey is very important for us. It will help us improve, and the university would require that we submitted, and so you would see our activities and stuff like that. So I would really appreciate it if you fill it before you leave and give it either to Dr. El Sayed or to Alvin here. Okay. And we may have 5 minutes if someone would like to use for coffee until we start. We'll wait for 5 minutes for the next speaker. So take a little bit of a break and then we can come back in 5 minutes. It's 3 minutes actually. So
Mike Paskett. Been asked to speak. We farm south and west of Gila Bend. I have 18 of these valley irrigation pivots. The picture simply to give you something to look at instead of having to look at me for a minute. We've been farming in Southwest Arizona for 9 years. We've been out there. And I don't know if it's because I'm lazy, but I've tried to do this with just me and my wife and my kids. And we have 18 circles. It's a lot of work. We have 6 kids, 2 girls, 4 boys. And they've rotated kind of in and out of Arizona because 4 of my kids are in Idaho part-time. And now they're grown. So the youngest is turning 19 at the end of this month. She's on the farm every day helping us. My wife Robin's youngest boy is full-time salary, and it's primarily me and him most of the time. So, and I tell you this because to manage this many pivots, I guess, this many acres, and try to do it efficiently, we look for everything that we can to make our life simpler. Right? So, give you a little bit of, the pivot themselves, our engineering on them, they're all gallon at 1,250 gallons a minute. They're 8-hour machines, so they make a full revolution in 8 hours. I typically run a 24-hour set, which puts down a little over half an inch in 24 hours. The design on them, our spacings are 30-inch spacings. We've got a regulator on every drop. So that gives me at the moment just shy of 10,000 sprinklers and regulators. The previous gentleman was speaking about the regulators, and the water quality is a huge thing on those wearing out. We have high bicarbonate, high salts in the water, and still trying to figure this one out, but it appears that approximately between the third and fourth year, those regulators we're finding some problems with them. So we're replacing them as we go. But we do a whole machine. So we'll replace, excuse me, we'll replace all the regulators. What we did is we replaced them all on 7 machines, and then we're probably going to replace 7 more machines this year. And then I won't have to replace any for about another couple of years. But anyway, to make our life easier, we've tried to utilize all the technology that we can, which is kind of what I'm wanting to show you. And I thought it would be easier just to show you how I do it and why. So, and this is just I got a drone the other day, and I was trying to figure out how to use it, and I thought, well, that might be something to look at. They're more difficult than they look. And I was hoping that I could just fly up high and take a good picture of the whole field and see if I had any bad spots or anything. But the higher you go, you need a very high dollar one to get the image that you want. I'm learning. And it's not a cheap one that I have, but it's southwest of Gila Bend. We're along the Berry Goldwater. Pardon me? Yes. South of I-8, along the Berry Goldwater. Historically, it was called the Golden Sands Farm, if any of you guys are familiar. How many people in here are farmers? Half? And half of you are trying to sell us something. So, we love you. So I can only speak to what I know. So the pivots, I know it says linear on the page. I do know a little bit about linears, but I'm really going to speak to the pivots and what I do every day. The same thing that I'm going to discuss pertains to the drip, probably, linears for sure. But the whole idea behind everything that we're doing is that we're trying to conserve water to try to produce with alfalfa, for example. We've been able to, in the 9 years, I got almost 12 ton one year. And I was at 10.2 tons last year. But we're trying to keep up the hay quality, the tonnage, and use the least amount of water as possible. Our water got a lot of salt. We don't want to salt out the ground. And if anyone has the knowledge here in that space afterwards, we can discuss that, because I'd be interested in learning. I'm conflicted on the idea of use a lot of water to push the salts down when you walk out there and witness salts want to move up. And to push those salts down, you're just using more salty water into your profile. So it's a struggle in Arizona. So, but I'll move on here. So we use AgSense. Rick's name's up at the top of the page there with his phone number. I didn't realize that until last night. I don't know how to remove it. So anyone can call him. But what I wanted to show you is, and we also grew potatoes. We grow alfalfa. We've grown squash, corn, wheat. I got 750 acres of wheat right now. Tap grass. I like the grass to try to pull the salt out. And we need the rotation. But I'm going to show you last year our water usage and the things that I can do with the software, which helps me to be able to use the least amount of water. And we have used the soil probes like they showed prior. I do find them useful. I've only had 2 of them, but they help me learn how quickly the water would penetrate between our hay cuttings, how quickly you could get that water back in the profile, get your moisture back to where you want it. In the soil type that we have, I think we'd need hundreds of them because it kind of changes. I've moved them around a little bit. And, you know, in one place, the water penetrated the ground faster because the soil is just a little bit different. And in another area, it might be a little more sandy. I said that backwards. The first area was more sandy. The second area was harder ground, more dense. I think I had a little bit more clay in it. And the water doesn't move through it as quickly. So I think it would be difficult for me, where other places in the US, I'm sure, would work really well. But it would be difficult for me to tie one into my VRI and have my machine slowing down and start, speeding up all the way around the field because the moisture probe was telling it needed a little more water or less water, right? I probe the field. I go out and probe in the summertime almost every single day with a physical probe. And then I utilize this AgSense between the two. And I also look at Azmet's evaporative transfer rate. Every single morning when I wake up, I look and see what it was yesterday. I look at my 10-day forecast and I try to predict about what I think the ET might be, which I don't have a crystal ball. And I don't know how much water you guys use. So what I'm going to show you might not be as good as I was hoping. But we try to use the least amount of water and get the best bang for our buck, I guess. So this pivot, the internet, a little different here, but so with this, you can control these from your phone. You can I have it in my office as well. I start them, I stop them, I can turn on my fertilizer. I can tell that I want to put a 1/2 inch down, and I do that from my phone from anywhere. And then they also text me if there's any trouble. If one shuts off or if there's low pressure, I get a text. And those settings are settings that you can set to whatever your liking is. If you're running, say 50 pounds, our system is all enclosed. So we pump out of a well, it never sees the atmosphere until it comes out of the sprinkler. So all the wells we've interconnected into a main line, and then they all spur off to the pivots. And that reduces our evaporation by a lot. Our nozzles are 30 inches from the ground. So once I have a crop that's, getting closer to it, it's really not evaporating off like it would if, say, your sprinkler were 60 inches off the ground. We try to keep the water out of the atmosphere as much as possible, if that makes sense. So what I do is I go on to AgSense and whoops. I'm used to using a regular mouse. And I go into reports. And I wanted to do this live so that you could see that I'm not full of shit, really. So pardon me. I live in the desert. I'm all alone most of the time. If I'm the farmer sitting here, I would be more interested in knowing, okay, what's it really look like? Versus I created a PDF or something that could be manipulated. So we're going to use the year of 2023. This was a hay field all year. And I've got a lot of crops in rotation or fields in rotation. So I wanted to use something that we could show a whole annual. So I just put in my dates. And then I hit generate. And where did my little slide thing go? On my screen, there's another little screen that shows me that's covering part of my screen up. Okay. So let me move this thing somewhere else. So I can come in here. This was a full year. And if you can see, we used 60.82 inches on this alfalfa field for the year 2023. And I know that my neighbors to the north that are ditch irrigating, they're just flood used. I talked to a couple of them and they used between 110 and 120 inches. So probably why I'm standing here is I relayed that to Dia and he thought that was a significant water savings to accomplish the similar. I know, and we really did get fairly identical tonnages from the drip, or I'm sorry, from the ditch irrigation, not drip, ditch. But we used virtually half the water, but I don't like to say half the water, but pretty close to it. So 60 inches. And then the other thing I like about this is you always have a problem with something. These guys mentioned gearboxes. We will have a gearbox go out or a broken U-joint or something that, or just in our regular maintenance that the kids move the pivot and it might get started in a, not in the same spot where it was sitting and you leave that little sliver of a gap. If you'll notice in dead center, I always have this, I think it's a software thing actually, but dead center, it shows the red. So we're at 60 inches all over the field roughly, and where we stop it and move it during the cutting, different things, service it. It's always right there on that same place because that's where our road is coming in. And it gives me a little bit of a skewed number right there. But if it's truly an issue, then I can see it on my graph and I can correct it. I can come back. Or you can use your VRI on the pro panels to, when your pivot comes around, it'll slow down and match up your inches and then speed back up, which I think is huge. But the more consistent that I can stay here throughout the year, all the way around the field, the more even the field looks. I'm kind of picky on the people come to our farm, they drive past the field and I want it to look a certain way, you know, kind of like we know what we're doing versus letting them know we're losing our ass. So I want to move to a potato field. Whoops. This whole laptop mouse is kind of getting me. I'm not sure why, but my circle's not opening up. I'm having technical difficulty. happening? Ah. All right. I apologize. So in 2023 in this field, this was a field of Burbank russets. So I would go to report. Those were only in the ground. We planted in the 1st of January and we harvested in the beginning of June. It took us a couple weeks. So I'm going to go from January 1, 2023 to June 30th. This is pretty easy, actually, when you're not standing in front of an audience.
Did you have choices for your data operating system? And you did have choices, why did you pick X?
It's easier for me to understand. It's pretty simple. I like that I can create graphs and charts. I like that it keeps my history. So, and I do print reports, so if there is some kind of, because I know this is all stored in the cloud somewhere. I don't know where. But I like being able to go back, and that's kind of what I was going to get at right here is, so on our potato field, we used 26.69 inches. And you can, whoops, this is a little touchy. I should have just used a regular mouse, but you can see we can keep some pretty good uniformity across the 125 acres is what this field, well, all of my fields are 123 and a half, basically. And I can see how much water I used in gallons. I can see how many inches that we put down. And then this is by the angle. So you can go in and say by the month and generate this other style of a report, which I think is helpful because I can see where most of my water, what month I used most of my water in the potatoes. And I can revert back to that the following year. And I can try to track it. I can try to keep, plan ahead for the upcoming season. What this does for me is it helps me with my hay rotation. So, because you only have so much water. We want to use the least amount that we can to do what we have to do. Potatoes are critical on the water. You'll go out and check them and you'll go, holy cow, yesterday it looked great, but we got to get some water on here. With hay, it's a little more forgiving, but I've got this whole rotation of all of my hay fields. And this helps me to know that, okay, last year and this week we used this much water. You can put whatever date you want in here. Just for the sake of this conversation, I'm using the whole crop so that you can see because we don't want to overwater and we don't want to underwater. And I can't do that if I don't have the data. And the AgSense tracks the data and gives that to me, if that makes sense. And I just like this stuff. So then let me look here. Like back to the maintenance that was brought up earlier. And the fact that I've been running my children from the age of 10 up through in the last 9 years while we're doing this. There's some things that, let me find it here. Forms. I can go to forms and there's a pre-start checklist. And with my younger kids, I would just go in here and what you do is you just print it and it'll print out this checklist and I will hand it to one of my kids and say, go grease the pivot centers, go check the gearbox oil. You pull they're pretty simple. You pull a plug out of the bottom of the gearbox because moisture accumulates. And so you'll drain that off and then you'll top it back off with oil is what we do every June and December. So twice a year we go through them. And then visually inspect the tires, or if I'm trying to keep them real busy, I give them a tire gauge and an air compressor and tell them I want this pressure. So anyway, this is how we track. And I don't know how much water you use on your alfalfa. It looked like farmer group was over here. You guys, what do you raise? Pardon me?
I can't help you.
You're just starting out? Don't do it. Pardon me? Is that with real irrigation, ditch? Surface, yep. And, okay, that's what I was wondering. Yeah, it's a sandy loam. Yeah, it's a sandy loam, and the closer you get to the river, it seems sandier and saltier. Salt's a big one. So. Well, I was nervous doing this because I haven't spoke in public for probably 14 or 15 years. But I did feel like it was important because we're currently in a situation where the government's trying to put us in an AMA everywhere. And I think it's important that we're friends about things. We learn from each other and we teach each other how to use the least amount of water to make the most of it. Water's not cheap. It's costing us about $70 an acre foot right now. And so if I could use 4 feet instead of 5, or if I could teach someone or help somebody in here to understand how they could use 5 instead of 7, I would hope that something that I said was of a benefit to someone else. That's really why I got up here. And that's about it for me. I just wanted to relay how we function and how we try to track our water, and I wanted to open it up to questions. And I don't hear very well, so when you ask the question, yell at me.
It's better that we ask through the mic.
Thank you. Sorry, you mentioned AMA, the government is trying to put you into an AMA. Just what is that? Yeah.
The AMA is an active management. I think the other A is association. Pardon me? Yeah. And where they'll come in and they'll regulate your water. What they don't understand is we do anyway. If we're trying to be a good steward of our land so that we can pass this on to our children, right? We do need our company. I named it FTW LLC, and it stands for Feed the World. And we believe that. We believe that we need to be a good steward of what God's given us. We buy a farm and we say that's my farm, but truly we're just we're the custodian of the land in the moment. So our kids, somebody else's kids eventually are going to be farming that. And I don't want to just farm it I need to make a living, don't get me wrong. but I don't want to farm it just for profit. We need to, you don't want to just suck everything you can out of it and then you're done and you're gone and you're driving a Ferrari. We need to be able to be sustainable, correct?
Can we delay it until the lunchtime? Because you're waiting, so thank you so much, Mike. I just wanted to mention that I went to his farm, I don't know, a few months ago, and I was really impressed of how he's very careful in the amount of water he applies, how he have a very, his field looks really good. And as he said, you would not see like difference in plant height or anything like that. So yeah, that's why he came here to share his expertise. So now we'll talk with, we'll have a talk from Monty from Dragon Line Company. It's a new system that's supposed to save more water compared to regular like center pivots and linear systems. And here is Monty. I believe he can talk about the new system.
Sure, I'll talk a moment while he's getting me set up here. I'm Monty Teeter from Southwest Kansas, Ulysses actually. And when I'm here listening to everybody, what you're doing, seems like we did this 20 years ago or 40 years ago, and what we're doing in our irrigation part. But we're in a deficit irrigation usually always with what we're doing. And I'm excited to come here and be able to share our information with you. I do have my wife partner with me, Jean Teeter, here in the back of the room. Also, we brought Brant and Amy Peterson. Brant is a 5th generation farmer that's been using pivots his whole life. I started working with his grandfather almost 50 years ago with pivot irrigation in our area. I used to have a large irrigation company that I had. We sold more than 3,500 pivots through that company in 45 years. So I've got a lot of experience with pivots and how to maintain and what to do. And as we've developed Dragon Line over the years, it's because of necessity. It wasn't because of a luxury, because we're only mandated that the most water we can use are 2 acre inches of water. And acre feet. Thank you, Brent. 2 acre feet of water. And currently on my farm that I bought, I only put on 9 acre inches a year to grow my crops. So we've developed Dragon Line to use less water to maintain sustainability on our farm. Also, we have Gene Reinert here with the Riverless Corporation that's with us here. And also, we have 3 distributors also here in the room with us today. Wyatt Myers from Water Associates, Joel Johns from Desert Drip, and Eddie Good for Rain for Rent from Yuma. So we're pleased to have those people with us. This works. That was going to work. So about 12 years ago, we started working with a new type of irrigation. I had been working with subsurface drip for about 20 years, other pivot irrigation for almost 35 years. And one time a hydrologist said, if we could save 25% of our water today, our aquifer would last 35 years longer. And for us in the Western Kansas area, we pump from the Oglala Aquifer, and we've mined 70 to 80% of that water in a lot of areas. So we're getting about out of that water. So we had to learn how are we going to survive because we can do anything, grow anything within 75 miles where I live. We process 20,000 head of cattle every day for meat. There's huge dairies. There's everything that depends on one thing, water. And so we set on the trek to try to develop a new product. And we call it Dragon Line Mobile Drip Irrigation. And this is just a little video that shares about what is mobile drip irrigation.
With pivot, Dragon Line provides increased efficiency by delivering water and nutrients directly to the soil, providing optimal plant growth by applying water directly to the soil and not on the plant. Dragon evaporation of the canopy. It also eliminates leaf burn, plant shock, and sudden temperature changes, and reduces potential for disease to the plant. Costly wheel drainage are reduced or completely eliminated since the water is applied directly and precisely to the soil behind the system. Its unique design allows for precise chemical and fertilizer application, as well as crop germination through the system. Dragonline systems are adaptable for low and high profile crops in any row space and can be used on most pivot and lateral irrigation systems. For more information on Dragon and to locate a dealer near you, visit dragon.net.
Since we started selling commercially, we're in over 20 countries now in the short 7 years. And we're also in 20 states in the United States. And so we've really made an impact with a little company in Southwest Kansas of 20 employees, for the world to help save water. This is the system that we use today, as we would call a traditional mobile drip irrigation system. As pivots have a span, that has a pipe that connects the system together, and they have a tower in sections. And we actually connect a manifold of cable and a hose manifold that has our Dragonline suspension on it. These hoses that come down off of our manifold are about 10 feet long, so they get all the water on the ground before they start emitting water. And then we have a tubing that connects to that that's actually drip irrigation. And we'll cover that in just a moment, how it works. But the length of the tubing dictates how much water we put out. So at the start, they might be a foot long. At the end, they might be up to 50 feet long. So we distribute that water out over an even spacing through the field. Over the past few years, we've been working with a lot of potato growers, PepsiCo and Frito-Lay and Simplot. And we've learned to make these spacings a little closer together on our manifolds to get more uniformity watering out across the fields. So we can make this spacing anywhere from 12 inches to 90 inches wide, just to fit what specific crop requirements we have. Then also during our development, we have a winch at each tower. And these winches can change the spacing of how the dragon tubing is dragging on the soil surface. So in conceptual and in fact, you water in a strip, you plant in that strip, you germinate your seed in that strip, and then you can move the tubing over 6 inches after the crop emerges. And also to keep salts, if I hear a lot of things about salinity, we can manage that salinity away from that young plant and keep it away from that young plant. Also, we deliver our fertilizers and chemicals directly to that plant rather than waste it in the air. So this is basic what we have, and we can answer more questions and show more samples in the back of the room afterwards. But the key to our system is an emitter that's pressure compensating and self-flushing. And it's 2 gallons per hour. It's the largest emitter in the world made for this precise irrigation project. As you can see, we have a huge flow path in our emitter. We have a silicon diaphragm that regulates the pressure out in the system. Once we reach 10 PSI, every emitter is putting out exactly the same flow. And we don't have to worry about regulators because it's regulating itself. And there's nothing in this piece that will ever wear out. So it regulates itself during use. As you can see, you kind of see we're watering a strip, water next to that corn, then we've moved it over. But we have a heavy 50 mil tubing. I guess rather than being short of time here, just look at our displays there. But it's a 50 mil tubing, very heavy, the heaviest in the industry, with our emitter inside. And then we have a little 1/2-inch end cap at the end. So if you do have contaminants that go through the filter system to the end of the system, like most particles and sand and stuff, or really fine or silt, you can't filter out silt, it'll go to the end of the system. You can take those end caps off and flush it out if you get to that point. This is a better picture of the winch system. It just adapts to our manifold that goes from tower to tower. So you can actually change these positions on the soil. And also we've developed different types of winches. If someone's going to be raising corn or a tall crop, we can actually raise our system up from a 4-foot level to a 9-foot level. Just by loosening our winches and adjusting our manifolds, we can raise it up to the top. So we can water short crops or tall crops. And also we can manage the spacing of moving them right or left. We'd have a new dual valve assembly to adapt to your current sprinkler head system. So if you have a current sprinkler head, we adapt it to a drop assembly. We come off with a T with a ball valve. So we can either open this sprinkler up or shut it off or turn the water on to our Dragon line. So we can either use, there's certain times some people may want to use their sprays to incorporate a herbicide or to do other things. On most systems today, we're not even incorporating any sprinkler heads because where we move the manifolds, we can do everything with our system without wetting the surface. This just shows a little example of where we started working with the Dragon line system with germinating crops. We were able to get almost 20% better germination and about 18% better yield by just getting the crop better germinated. But keep in mind, and I didn't tell you, but my farm only has 200 gallons a minute and I water 2 pivots with that. So not at the same time, but I rotate seasonally and I grow wheat, corn, or milo by rotating that water. So I don't have the luxury of putting all this water on and dumping the water on to germinate my crop. I do it precisely. And once I make one circle, that strip of watering will last 6 days. And it's long enough to get the crop up because I wet about 6 inches wide and 12 inches deep, and it stays around that seed, germinating it, rather than cooling the surface every day and stopping that germination from happening with the sprinkler heads. This is a good example. This actually come from one of our growers in Mexico. He didn't have GPS, so he put our system on, made a circle, found out where the lines were dragging, and then he planted right on those lines, and then he germinated right on those lines. So even if you don't have precise GPS, you can make our system work, and then you can adjust it right or left to fit that spacing if you get off a little bit. This is something else we've developed to go along with the mobile drip irrigation. Once we have the flexibility of the lines on the ground, sometimes maybe you want to grow a different crop or change your spacing. So this was a typical farmer, or not typical farmer, but a farmer that had 34-inch spacing on his Dragon lines, and he wanted to go to a 68-inch bed to grow squash. So we went on and we made a little bar to pull lines together to water on top of the bed. And this would be the configuration that he received. You just water on each side of that little plant. So with transplants or any other types of materials or plants that you would plant, we can precisely water on each side of that and keep that plant wet. And you eliminate all the weeds growing out there on the rest of the ground because we're not germinating weeds. We just wet the seeds. This is in Paraguay, how somebody's used our system to pull more lines together to water on top of beds. They raised organic sesame seed and onions and then some potatoes. So that there's a lot of flexibility in what you can do with the mobile drip irrigation. You're not just set to any one fixed product. This was actually watering some potatoes, our first go at some potatoes. They were worried how the lines would stay on the rows, and you can see how they just followed the rows precisely. At first we planted in circles, but then on potatoes we found out if you just have a flatter bed, we can water across those with 15-inch spacing and had excellent uniformity. But you can see how the water is going in. This farmer always dikes because they have runoff. We eliminate runoff. We eliminate wheel tracks, and we put the water precisely where we want to. This is alfalfa growing with a center pivot. Our wheels are always walking on dry ground. When we talk about maintenance on systems, it's been 7 years since I've had any maintenance on a gearbox or a motor on my farm. We just walk on dry ground. I once in a while have to air up my tires, but where you're walking on dry soil all the time, you just eliminate all that wear and tear and mud and work on those pivots. So we believe most farmers will say they extend the life 75% on their gearboxes and motors. And this is how Dragonline actually works, or mobile drip irrigation. Through conventional systems with, these are 60-inch row spaced sprinklers, 18 inches or 24 inches off the ground. And keep in mind, I only have 200 gallons a minute, but this is watering 1.25 inches of application in one revolution. And you can see as we water with traditional nozzling, we wet the soil particles and we create separation of the clay and silt particles. And they start settling out in layers, and you start creating compaction and sealing in the soil. And in the same picture here, where the Dragonline's running, you know, we don't have any runoff. All that water's going in the soil. We wonder, why is that? Well, here's what happens. Just a really simple concept, but it's very factual and it is real. But when you're watering through sprinklers, you wet 1 to 5 inches of that soil thickness, that top thickness, and you trap air in the soil. And until the air gets out, the water can't get in. That's why we start trapping water on top of this, on top of the soil. And also, each time you water, you push your herbicides and your fertilizers deeper into the soil. With Dragonline, we water in a long, thin strip. That water goes into the soil in a long, thin strip and moves with capillary action sideways. And so the air, the water moves into the soil and the air comes out. And your wettest part is going to be in between where the lateral lines are watering. It's where the two bubbles come together. That's going to be the wettest point. So instead of bubbling off your water and leaving it to evaporative losses, we put the water in the soil, and we're 95% efficient compared to subsurface drip irrigation, according to K-State University research studies. So you can pull up some of those if you wish. But it's very efficient. Most pivots will be 60 to 70%, and we'll cover that here in just a moment. This is what happens with a lot of your water, and this is a USDA study done by the USDA down in Bushland, Texas, by Steve Evett. And what it was a study about is a 2-year study to show how much water evaporative loss we have watering bare soil. And whether you're watering alfalfa or some crops that don't have much leaves during most of the year, you're evaporating a lot of your water watering bare soil. And what this test shows is applying 1.2 inches of water and measuring the evaporative loss over a 2-day period of time. And at the end of the 2 years of study, clay loam soil loses 67 to 79 hundredths of that 1.2 inches of water, almost 65% each time you water. Silt loam soil or sandy loam soil loses 47 to 60 hundredths. That's still half. So every time you're darkening that soil, you start losing water to the atmosphere. And that's what we do with our mobile drip irrigation. Instead of wasting it into the atmosphere, we're just putting it into the soil. And that's how we can say we save 20 to 50% of the water being used. And this is very important here. If you water more than 1.2 inches at a time, your average loss is 47%. And if you water less than 1.2 inches at a time, your average loss is 70%. So that just shows you've got to put more water on each time you irrigate, because each time you water, there's a certain percent that you're going to lose. So the less frequency you water, the more water you're going to save. So you want to put more water on each application. This was a study done by K-State. We've donated a pivot to them to test mobile drip irrigation. And they show about a 35% difference in evaporative loss before the canopy closes on corn. The difference between our nozzles or our Dragonline versus traditional nozzles. And this is probably real important here. Traditional sprinkler heads deliver application efficiency is greater than 90%, 95%, some will say. But that's application efficiency. It's not the use of the water. But when that water leaves that nozzle, that's when you have losses occur. Let's get that off there. Okay. You guys can understand what happens, but this is probably a 90 to 95% efficient application package, but it's not when the wind's blowing and the sun's blowing and you have terrain differences. This is this is probably going to be the same thing. Yeah. This is spray nozzles. You know, they're blowing your water in a lot of leaves. This is bubblers, you know, in the wind. You know, they blow around and distribute water differently. Hope this is not too. Can we shut that sound off?
I think you're fine.
Huh? Except, well, my dragon line lays right on the ground. It doesn't even move, you know. One farmer said, one amazing thing about dragon line is the water never sees the daylight. It just goes directly on the ground and into the soil. So I wish that would, you guys could have seen that a little better, but that's kind of what's going on there. Bas could talk about a little bit of maintenance, and we're getting close here to running through this very fast. Really, the only thing we have trouble with Dragonline, it is a drip system, and we just need to remember that it's a drip system, and we treat it as a drip system. It's not as critical for the filtration because we have such large emitters, but we still do need to treat it like a drip system. First thing, when you adapt to a pivot, sometimes somebody's pivot might be all junky and about ready to fall down anyway. We've never had an experience of a system falling down by connecting our system to that. But if you look at the big scope of things, we only add approximately 300 pounds of hardware to that span. We eliminate wheel tracks, so you have less wear and tear on that tower. So we've never had anybody say anything about creating any extra drag on that pivot. The tubings drag on wet soil, on leaves. There's very little drag on that pivot, but we just want to make sure that before you adapt this to your system, that you have a sound system to adapt it to. We're just talking a little bit, once you connect the system, we'd like to go through there and where we have this dual valve here, you know, you shut off the water going to the dragon line, open up your sprinklers and flush your system out good. Take the end cap off the end of the system, get all the sand and contaminants out of that system. And then when you start up, go to your system, you will then turn your nozzles back and go to your dragon line mode. This is actually a potato system here showing, you know, it is a drip system. We need to treat it as a drip system. So we usually always do a water test, which everyone has talked about, getting a water test first thing. That way we can determine what kind of contaminants are in that water in case we have algae issues, iron bacteria, different levels of contaminants in the water that could cause clogging issues. And then chemigation is very easily to adapt our system. If you do have those issues, we have solutions to take care of them. The biggest thing that'll happen to a system is organic materials. This just shows a emitter that's clean, and this is what can happen if you don't treat those systems. Just like a subsurface drip system, you have to manage the bacteria that's in the water. And we have, I've got some guides for the people that are here that want to follow this or go online to our website. We have all this information on the website also to talk about these. Also, iron bacteria will clog filters. And you think, oh, well, this is bad. But, you know, we have these little tiny pumps, small pumps. They just use a small amount of volume of either chlorine or hydrogen peroxide that we inject right into the system. And that'll control any damages that you'll have with those, iron bacteria. usually you'll have less than 1 part per million flowing through that system will keep all those contaminants at a user level. We always want to manage the flow of the pivot properly. We always want to make sure we have 10 pounds at the end of the system so that all the emitters are working properly. And we usually use a gauge to go to the end of the system and check the pressure at the end of the system. Also, checking the pressure. If you have an increase in pressure, it's usually coupled to something maybe getting clogged up or there's some problem. So that we have some ideas of what to do there. If you have decrease in pressure, you might have a leak somewhere, which there's several things that could would go forth to that. Where I'm running short of time here, I really okay. Okay, and your question is, how do you manage the application of rate? There's a sprinkler chart that comes with the system, and it's just like a regular sprinkler chart. It shows the percentage of time that you water and the amount of application that you want to receive. So you can do that. Yeah, it's time. Mm-hmm. I could go through each one of these, but if you want to get a few, some of our literature, we have all this on it in the literature, but it's just, we have troubleshooting. If you do have issues, we have reasons and ways to help what you're doing. One thing that some people don't ever consider is their drip oil that they're using if you have a deep turbine pump. Turbine oil is not user-friendly to drip line systems. And Chevron makes a very good soluble B oil that biodegrades in the water, doesn't cause any issues. And one thing to remember that iron bacteria or algae thrives on oil, petroleum products. And so you take that away from it, you're going to have less contamination of iron bacteria. We always recommend planting in a circle, if possible, for high forage crops. And the reason for that, if you can kind of see in this picture here, you can see how the lines are dragging down into the crop. And on tall crops, if you're watering and you try to reverse out in the field, you could have all those lines catching on those corn plants if you watered in straight rows. If you plant in a circle, they'll just curl around and go back the other direction and never even catch on the plant itself. It's not mandatory, but we just would recommend you do that on the high forage crops. On shorter crops, it really doesn't matter. But on row crops, it really is nice to be precise in your watering. Also to help manage with winch systems and being able to adjust your row spacing. It's very important to plant in a circle. This just shows some germination from different things. This is on peanuts. Actually, we tied lines together and then germinated the crop and then cut them loose and water on each side of these peanuts. This is germinating corn crop with very little water. We have a lot of filters. There's been a lot of talk about filters, whether it's disc filters, sand media filters, or screen filters. We use a lot of screen filters in our applications. We found that they work very efficient. Disc filters are something that can be very good. Usually we don't have the water or the luxury of wasting water with a sand media filter because it takes so much water to flush. And so with these filters, with 200 gallons a minute, an automatic filter will flush about 8 gallons to clean itself, and then it gets to going again. So we use a lot of these automatic filters. Most automatic filters will require 30 PSI to flush properly. If you don't have 30 PSI, then we use a lot of semi-automatic filters, which require about 15 PSI. This is just a chart that shows a pressure variance of diagnosis. For example, if you have a large pressure drop across the filters, you probably got something clogged in the filters. If you have a gradual pressure decrease, you could have trouble with your pump, or they could have other supply problems. If you have a sudden decrease, you probably have some broken line or something going on there. If you have a gradual pressure increase, you probably have some emitters that could be clogging, or there's some debris getting in the emitters. If you have a really sudden pressure increase, you probably have a control valve plugging or your filters plugged in the system. And if you have a sudden pressure decrease, you probably have a broken lateral line or something like that. But it's just pretty common sense things usually. MDI can use to reduce fertilizer costs. Usually with most pivots, you're going to have slippage of those tires, and you're going to have 15 to 20% slippage. And no one calculates that in, so you're usually over applying chemicals. But with MDI, if you put 100 hours for a circle, you're going to make a circle in 100 hours. You know, you just need to make sure that any of the fertilizers or chemicals that you use are labeled for drip irrigation use. And winterizing at the end of the season, everything self-drains. But if you know that you've got some contaminants in the end of your lines, you should take off those end caps and flush the ends of those lines. If you know you have iron bacteria, you should shock it with some chlorine, 5 to 10 parts per million. That'll keep the bacteria from growing in those lines during the wintertime also. Drain your filters to your manufacturer's specifications. And be careful watering in freezing condition with automatic controllers, which you probably don't have any problem here. This is one thing that we do in Western Kansas and areas where we have a lot of badgers or coyotes at the end of the season or off season. We have a little clip that picks our system up off the ground. So you don't have the rodent damage and you don't have an issue. And then at the start of the season, you let those down on the ground, walk your pivot forward, and they straighten themselves out. So that's my part of my presentation. Do I have any questions real quick? None. Okay, well, I'm going to bring up Brant Peterson here. And Brant is, like I said, a 5th generation farmer in Southwest Kansas. He and his wife are here, and he's going to give a little presentation on his experience with Dragonline.
Well, hello, everybody. Glad to be here. So yeah, I've been a 5th generation farmer, Southwest Kansas. Size and scope. When I started, we had like 6,000 acres irrigated corn, 4,000 acres irrigated wheat, and a lot of dryland farm too. Had 50 pivots, 43 irrigation wells pumping out of the Ogallala. Since then, the aquifers declined a lot. We've done some division of our farming operation, so I farm significantly less now, just because we split it up and I was just getting tired. So I've been up at the big size and I've been down to the small size and I'm in between. But so my experience with center pivots is vast. So Verus is a electrocontact EC, electric continuity test of the soil. So you can see the red is a sandy area of this field. The blues are really more tight and everything in between. And this will all make more sense later. But this is the deep Verus. This is the shallow Verus of the field. So here's my filtration system. So we have, this is the sand filter right here. What we did is we just put a plug here, brings the water up over through the sand filters, catches in here, over here through the screen filter, which has a manual flush on it out there. And then these 2 pressure gauges here are critical, so you can just tell how much restriction you're losing between the filters. And then a little air relief right there, and then right back in the pipe, and up and out it goes. Pretty simple. Okay, and I'm going to go fast because they told me I had to. So this is the sprinkler reversing. This is how the lines will lay back over. And just for reference, this is a 1983 Zematic, back when the galvanizing was good and the pipe was good. And we just retrofitted this sprinkler, this Dragonline right on that, so they can make it work on anything. So here's a little video of, shows the 2022 crops, I believe, or 22. This is going to be wheat and not gonna make you suffer through all that. This is 125, 122 acre pivot. I generally do half corn and half of another crop. The reason I'm doing that is to offset peak water use or demand. So this is corn on this side. This is wheat on this side. There was like 5 inches of rain in 2022. So there wasn't a lot here. I'm not gonna say that I got Arizona dry, but we're dry. We're in the far southwest. We're 20 miles from Colorado, 40 from Oklahoma. Okay, so I got 200 gallon a minute on this 120 acre circle. I do 60 acres of milo sorghum or wheat and 60 acres of corn annually. Here's a picture of the corn when it's 5-6 foot tall, pre-tassel. It's another picture. This might even be a video. I can't remember, but what I'm showing here is just the uniformity in this field. This sprinkler originally had 8-foot spacing, and now we're down to 30-inch spacing with the dragon line. And I think this one's the video. Yeah, this is tassel. So it shows we're dragging the dragon line through the tassel a little bit, but it doesn't seem to hurt anything. Oh, no sound. Thank God. Yeah. So one of the things that was really cool about this year, my aerial applicator, when I asked him, I said, how was the field when he put the comite on? Because we got mites, spider mites. And he said, that's one of the 3 best, most uniform fields that he flew the whole year. 2022 was a rough year. Here's a sorghum that I grew in 23. Shows planted it in a circle. You see the corn in the background, same type of thing. Sorghum uses a lot less water than corn and also offset the peak water use. So, you know, the corn over there is tasseled, and then look how, what the maturity of this sorghum is. So that's how we manage less gallons is one way is we offset peak water use. Here's a pretty cool picture from my pickup in that sorghum. You can see in the mirror, that's the pivot road where I go and check the filters and all that stuff. And that's my pickup sitting in that sorghum. It's fantastic sorghum. We enter a yield contest every year, and this year we took second nationally in irrigated sorghum. I think it was 214 bushel, and that was on this field with water that was shared with corn. Okay, now here's an interesting deal here. So I think this might blow some minds in here. 2021, I used 147 acre feet on the 120 acres, like 1.2, 1.25 acre feet per acre. This is the wheat use here and here. This is the corn use. Now, like he said, the pressure transducers and all that stuff, it up and down a little bit. It didn't always, like, it ain't perfect, but this is the baseline of water that was used for corn. This is the baseline water used for the wheat. The following year, 2022, the bad year, I used a little bit more, but still very respectable in the amount for what we produce. Here's a map. Now, one thing I had this year, I had it custom harvested. So each one of these circles that looks real poor, that's because there was a wheel track in that header and they didn't shut that row off. So it was cutting 11 rows, but figuring it as 12. So that's why those are in there. And I want to show you this, and that's now we're going to tie back to the embarrassed maps. So as you can see, each one of these little pockets where I had challenges in my field correlate directly to the soils. It was a rough year. So I was wondering, is it, okay, what is it? Is it my watering? Was it the dragon line or whatever? No, it's the soil. That had I known, I might have cut population back. I might have changed a little bit, but I'm not real good at reading the future yet. Any questions? I went through that real fast. Happy to answer any questions. Yes. If you keep the raccoons and the coyotes and that out of it, and you run your, so I shock it with chlorine in the spring and in the fall, and then we tie it up. And if you keep the raccoons out of it, and during 2022, there's times when, like he said, the pressure gauges are critical. And even you guys that don't have Dragonline, pressure is critical. And I had to get down to a 4-inch water meter because the other water meters were just jumping around too much. So I had to get down so I could precisely see how many gallons I'm putting through the sprinkler, and I measure the pressure. So if the pressure goes up, but the gallons stay the same, then I search for that problem. If the pressure goes down and the gallons stay the same, I have a leak. So we had raccoons chewing the tape during the year in 22 just because it was an awful drought. We also had antelope way farther east than we'd ever seen them because they were trying to get a drink somewhere too, and the irrigation is heavier going east. But yeah, if you do the things you need to do for maintenance, then it'll last a long time. I'm on year 5 now. Yes, ma'am. The Varus? There's a grower in my area who's kind of a soil nerd and everything, and he has a Varus rig, and it's a sled you pull behind the pickup, has a coulter that runs in the ground, and it's, sending signal down and coming back and measuring that, and he just pulls it behind a tractor and measures does a deep and a shallow at the same time. Then we make our management zones based on that. Then we variable rate fertilize, variable rate plant, et cetera, et cetera. To make a grid, yes. Still have to sample to our management zones, yeah. Yes, sir. Well, like he said, necessity breeds invention. We had to figure out how we were going to remain viable and profitable with less water. Also, at the same time, like the gentleman before me was talking, we have to be good stewards of what we're charged with taking care of during the time we're here, right? So this field, I have 1 well to 1 sprinkler. The other stuff I grew up on was 8 wells to 24 sprinklers. So not a lot of rotating water on that, not rotating on this. This is where I want to try it first. But I needed to do something to the sprinkler because my gallons had gotten so low with an 8-foot spacing between drops. My yields were terrible just because of the inefficiency of the water to shoot that far, right? So I was going to have to do something to add drops to the sprinkler to get it closer because I just had less water and couldn't reach. And I'm like, okay, well, I've done this other way for 30 years. Let's take this new type and let's get down to 15-inch or 30-inch spacing. And the other thing is when you get down to, like I said, I'm talking to a different group here that I'm used to. When you get down to 200 gallons for a 1/4 mile system, the nozzles can only go so small. Okay. So we typically have to overwater the first 2 or 3 spans by 18% just because we got a 4.5. I got a whole span of 4.5 nozzles. You're going to tell me that the first 4.5 puts out less than the next one, or the next span and a half is number 5 nozzles. And so the beauty of one of the things that really took me to Dragonline was I could, by cutting the tape 1 emitter off versus the next one, I could micromanage how much water came out of that drop of that line. And so where we traditionally were overwatering 18% in the first 2 towers, that's my smallest acreage, right? That's the small circle. Now I can apply the right amount of water where it should be in my bigger acreage. And so that alone made a huge difference for me. And that's how I can do with mine. It's actually 190 gallons, but we round up 200. I can do with 190 gallons what guys are doing with 300 gallons. And has a lot to do with, one, the right amount of water in the right spot. Two, not the whole percolation and watering the soil and getting it down exactly where it's there. And those are the two biggest things. And when you watch the videos that he showed of the wind blowing and everything else, if you were spraying, we call that off target, right? Maybe drift, but we call it off target, right? So that's off target irrigation. One of the things, back to regulators, I will put in just a plug for regulators. When you're pressurizing your system and you're reading the gauge at the end and the gauge says 12 pounds, depending on how old your sprinkler or how much blockage it has or how many gallons you're trying to put through it, you might have 45 pounds at the pivot. If you don't have regulators, what does anybody in the room, what does high pressure small nozzle do on a sprayer? Small particles and drift, right? That's why regulators are critical, because you want the right amount of pressure at the nozzle tip to control your droplet size also. That I'll give you for free. That was an expensive lesson that I learned. So regulators are critical. And I don't believe you have to replace them every 3 years. What we do is what we call shock the regulators. We fill the sprinkler up with water, and then we'll hit it with a pretty hard pump, and you can just watch them pop. So as they get a little bit older and as they get a little sticky or something, just punch them. They'll work. Any other questions? Yes, sir. Static water level varies between probably 280, 250 to 350 static in the winter. All our wells are sitting around 600 foot deep. And then if you guys are groundwater guys, Kona depression, the whole thing pumps down and everything else, and falling water figures in, but that's a whole nother speech in itself. So pumping costs can be really a big deal, detrimental for us too. But I don't pay as much as the other guy did at $70 an acre foot. We usually run somewhere in the 95 to 125, 130 dollars an acre for corn. Sorry. Hey, thank you guys.
So now we'll have lunch. We are almost ready for lunch, and for Zoom participants, if you would wait for us until we come back. Thank you so much. Very good. Hi, everyone. So we'll continue our workshop, and now our speaker is from Swan Systems Company. And the title for their presentation is Turning Water Management into Business Outcomes. Alvin, can you help him with his presentation? Let him share the presentation.
Can everybody see the screen? Can everybody hear me? Hello, are you connected? Okay, I think we are connected and everybody can hear me. Hi, my name is Kevin Rost. I'm with Swan Systems. Great, so I got confirmation we can hear. Yeah, and I'm based in the Central Valley, California, but I've been working up and across the state into Utah, Nevada, even Washington, Oregon, and now down in Arizona. So definitely have a really extensive ag background. Just a little bit about myself. I also farm pistachios, tomatoes, and onions and garlic. I teach ag classes, and I've worked as a farm manager and ag consultant as well. And so just, the last 5 years, my passion has really grown towards water management. I feel like, Swan Systems was a really valuable solution. So I definitely went to work for them full time to help bring that to the market. And, as we talk about, I want to thank all the other speakers today. It's been really revealing how many challenges, we're facing with water management, whether that's systems, techniques, the science, or technology. There's a lot to manage out there. And so our goal at Swan System is just to sort of try to bring all that together and streamline and automate some of your decision-making processes like water accounting and scheduling. Let me see here. There we go. And so sort of that's what the main objective of Swan Systems is. And it's a real high-level overview. Swan Systems is a software solution. We are hardware independent. So that being said, we don't need any hardware to function, but where there is hardware, we have over 110 and growing constantly integration partnerships. So any sort of telemetry or technology out there with an API, we can bring that data in and house it in a central website and begin to make use of that data for actionable planning decisions. What I like to say is sort of what it's all about is 3 things. What's my budget? What's my allocation? And, how do I, at the beginning of a season, create an annual irrigation strategy based on those allocations? I work with growers who are in, let's say, 20 plus different water districts. They have surface water, well water, reservoirs, and so planning all that at the beginning of the season becomes really important, especially here in California. And I'm sure where you're at as well is, we're under some really strict water mandates now. And so what's the budget? And then what's the plan? And so with the planning, we get really precise and really accurate on what that crop needs. We do that through recording and logging what your specific irrigation specifications are, your soil type, your crop type, your root zone depth, the environmental issues like ET, weather, and one of my favorite components of it is the crop coefficient library, which we'll look at in a second. And then at the end of the day, how well did we do? So what was actually done? It's the budget, the plan, and what was actually done. And so in Swan, we have a whole host of reporting measures, call that the impact module. So at any point during the season or after the season, We can take a look at how well that crop performed, how much money we spent to perform in that manner. You know, what was my crop yields, my quality, how much water did I use, and really open up that data and see where we can become more efficient and gain more progress or profitability with the program we're running. And then one of the, you know, real special features in Swan is what we call the system suggested irrigation scheduling. And so, you know, I have growers in parts of the world, like in Australia, for example, that have hundreds of pivots. And even with the hundreds of pivots and different commodities growing in different locations, when we put that all into Swan, you can schedule those in a matter of minutes. Essentially, once everything's dialed in and calibrated, you can literally click that button in less than a minute, schedule all your sites for the week. So Swan is a climatic and predictive modeling tool. That's why I said we don't need any hardware. We are predictive and climatic on soil moisture balance as well. And one of the unique things is that we can give you a 7-day predictive analysis, a predictive outlook of your soil moisture balance and your weather and your irrigation scheduling. So just a quick slide here on crop coefficients. This is my farm here on pistachios. I like to break my coefficient, which ends up being that ideal ramped water use demand curve. I break mine into phenological growth stages. And what gets really exciting is when I can really dial in the dates that those phenological stages are starting and stopping. So that's where I'm getting really precise on the water demand for that tree or crop. Just a quick slide on one of our, this is on the dashboard. So this is something you're constantly looking at when you log in. This is what is my water budget or my allocation and how am I performing against that. And there's some deeper analysis tools available. So we can, if we're tracking over budget, sort of take a look at and from the agronomic perspective, why that's happening and if we can make changes in that season. So at the end of it all, this is one of the impact reports. And, you know, in the green there on the top graph on the green, you're looking at what was the crop's water demand. In the dark blue, you're looking at how much irrigation was applied in that given month. And the light blue would be rain. And so this looks fairly good. This is probably a fairly good report card. At least on that side, I see some that are, you know, extremely off, either overwatered or underwatered as well. And that becomes really important when we're planning and looking for ways to become more efficient. And at the bottom, we're looking at a soil moisture balance status at any given point in the season. We can run that report card and see what period of the season are we on target with our goal, underwatered or overwatered. So this is another feature we're offering as well right now. We call this a retrospective analysis. So if you have site maps and boundaries and you have your irrigation specifications and crop type, those type of things, and some irrigation records, whether that's through telemetry or even a spreadsheet or pen and paper or notepad, we can bring all that data in and run a retrospective analysis, just like you would if you were a Swan customer, and sort of look at your performance and really open it up and see if we can create a plan to become more efficient. Like I mentioned, we're hardware independent, but we are integrated with over 100 partners here, anything from your soil moisture probes to weather, irrigation automation. For example, we have what's called a talkback feature. So all your scheduling is done in Swan with the click of a button that's automated for you. That could be on a site-by-site basis, a crop basis, or even soil type zone variations with if you have the irrigation capacity to irrigate to zones. And you schedule in Swan, you click another button and it pushes into the controller for execution. One of the next speakers is Rubicon. We have a really powerful relationship with Rubicon on their flood automation, which you'll see here in a minute. Working on some really, really awesome projects together in the Imperial Valley region. Same thing with weather. And then in the data hub, that's another feature we have. That's a data hub can be customized. It's another portal in our platform where you can bring in basically any sort of data you're collecting. It could be engine pump vibration to granular weather, it could be soil moisture, it can be anything that's being recorded, runtime hours on a diesel motor, for example. Any of those things can be brought into our data hub, and our developers will create a custom dashboard for you to observe those data sets that you're looking at multiple sources for, and even create like custom widgets for specific observations or outcomes you're looking for. If you have any questions about that, yeah, please don't hesitate to contact me. So, what we're really focused on is optimizing technology and optimizing your business decisions and outcomes and goals. So we're collecting all the data, whether that's, I have growers who text message me, growers who fill it out themselves manually. I get pictures of flow meters. And then I have farms that are fully equipped with telemetry, like pressure switches and flow meters or automation, and I can collect all that data automatically into the system to keep the records. What's really important is what was actually done. And so however that takes place, we can facilitate that depending on how it's done on the farm. And then, like I mentioned, we're simplifying the irrigation scheduling, very accurate. If you have moisture probes out there, we can bring that moisture probe and overlay it on our predictive moisture balance and use it to sort of fine tune the model if needed. But probes are not necessary with our software. So we give you a 7-day predictive schedule and a 7-day predictive moisture balance reading, which becomes really helpful. I use that tool in my farming practice because it helps me to plan my labor or tractor work or different cultural practices. I'm not drying down too soon, those type of things. I'm able to really predict and plan and prepare for any sort of dry down event or tractor work or something that I might have. And that's been really helpful for me personally. And, it's a very powerful water accounting tool. So everything pertaining to your water usage is housed in a SWAN. And you're able to, maintain your ESG goals, manage compliance, like in my area, it's Sigma now, and manage your annual water use accounting. We offer daily spatial imagery through Planet. So that gives you the ability to identify agronomic issues, track and monitor growth rates, set parameters for your agronomic outcomes. We also have a nutrient planning component. Same thing. SWAN doesn't recommend nutrient plans, but in there you can budget, plan, and what was actually done to keep track of your nutrient applications. Once again, you have powerful reporting there. Click of a button, you can produce your nitrogen management plan summaries, for example. So very, very useful planning tools there with the nutrients as well. Another thing we can do on there is in a lot of situations where I farm, we have extremely salty water and high boron, high chloride, high sodium. And so I'm able to upload water quality analysis as frequently as I need to into SWAN, and it keeps track of what's coming out of my water into my soil for me. So I'm constantly able to graph that and pay attention to those things real easily as well. And like we mentioned, the custom reporting, water use efficiency, water application efficiency, what's my budget to actual at any given point in the season, I can open those up, look at how I'm tracking, how much water do I need to finish the season, those type of things. And with the impact reporting, we get to set goals. Oh, am I running out of time? I think I just got a notice. Oh, no problem. Yeah, perfect. Yeah, if anybody's got any questions, they get to talk about how we help you with your systems, but I can leave this here for a second. And please don't hesitate to contact me if you'd like to demo or if you'd like to consider doing a retrospective analysis with me. Thank you very much.
Okay, any question? Good. Thank you so much for your presentation. And now our speaker is Yuri from NDRIB. The title for his presentation is Gravity Micro Irrigation System.
Good afternoon, everybody. My name is Uri Segev. I'm the VP of Business Development for NDRIP here in the US. First, I want to thank DIA, the extension and the university team for having us over here. And just another great chance to hear a little bit about the technology that we believe we need them here those days more than ever. Quick, I'm going to start with a quick story about NDRIP and actually the way that NDRIP idea actually born. Probably around 2013, maybe around 2014. Maybe I should say that NDRIP is technology out of Israel. And in one of the meeting around 2013 or 2014, which I believe involve Netafim, a question was asked to Professor Shani that at the time was serving as the water commissioner of Israel. Why we have such a great technology in terms of pressurized system, micro irrigation system, and for almost 60 years, and we barely covering 3% of the global irrigated acreage everywhere. Still, flood irrigation count as the biggest irrigation system worldwide. And the answer for that question is fairly simple. It's the cost of high energy. High energy is just in many places globally, worldwide is unavailable. You can't reach that, and the cost of building those infrastructure just enormous. And for most people who want to adjust their irrigation system, dealing with such a large expense or investment, it's pretty much it's a no case. So I want to say the moment after Professor Shani started working on the NDRIP idea, and I'm happy to be here today after 5 years in Arizona. NDRIP, or actually it's 5 years in the US. We came here back in 2019. And we've been in Arizona, actually our corporate office sitting in Phoenix. So to start, I want to start quickly with the technical aspect of NDRIP. What is NDRIP? NDRIP is a gravity-powered micro irrigation system. It's pretty much carry all the benefits that you can get with any other micro irrigation system without the need for high energy and pressure-based filtration that are necessary to sanitize or clean the water before they penetrate into the system. The NDRIP technology is custom and actually was made to work with unfiltered water. And I'm mainly talking about surface water. I would say large majority of our work right now is actually happening around the Colorado River Basin. Without any filtration, water coming straight out of the canal, out of the river into the canal, and flowing pretty much directly into our system. The NDRIP system is rely on the existing infrastructure, where pretty much everywhere you're working with flood or furrow irrigation with gravity irrigation system, NDRIP can actually adapt to that field at no time without changing none of those infrastructure. The slope and the fall that you have in the field in both direction is actually the force that NDRIP utilizing in order to run its system in I will say probably around the average is around 85 to 92% efficiency, which is a huge improvement from the low efficiency flood system that as we know it.
The NDRIP system is not limited to any water source. It can adapt to any water source, whether it's surface water that being delivered to our field through via the canal system. And it can easily hooked up directly to a well, into pumps, and operate as efficient from a well without changing any of, once again, any of your infrastructure. What you see here on the scale, it's a sketch of the way that NDRIP, oh, I cannot. That would be better. A scale of how NDRIP actually is being positioned on the field once we actually hook it to your irrigation canal. There is a small, usually 20 to 30 feet main line that will run the water from the water source, from the canal, into the head of our system, which is the water tank, probably in the size of 200 gallon, that's sitting on the, probably on the highest point in the field. That water tank, the black tank that you see in the corner, have two main purposes. The first purpose of that tank is to regulate the pressure in the system at all time. And the second purpose of that tank is actually to assist us fertilizing and sanitizing the water from a central location. From that water tank, we're gonna run out our sub-main that have two options. We have two options to go with our sub-main. One option is above ground, which we're gonna utilize lay flat hose, which I'm sure you're all familiar with. And that will be, once again, that system we're gonna be able to move it to another field next season if that's actually what the rotation require. And the second option is to actually go with a permanent solution, which is subsurface PVC line that's usually sitting at around 3 to 4 feet below the surface. That's our preferred way to install, from a simple reason. Staying away from any implement that's running on the field. It's always a much healthier environment for any system that we're going to put on the field. From that sub-main, we connect our lateral that's running straight into the field. And NDRIP system require a minimal head pressure of 18.5 inches. That's all we need in order to efficiently run that water throughout a quarter mile. In Australia, actually, we broke the record, and I think they're running over 2,000 feet system. Not highly recommended, because the longer you run your system, you're gonna lose the efficiency rating on the system. So we highly recommend to stay around a quarter mile run. Longer than that, it's might gonna require some additional design overlook into the system to make sure we're not losing any yield potential due to a reduction in efficiency. I'm happy to say that that's how simple is the system. I'm trying to think what else I can give you in terms of the technical aspect, but like I said, we have the main line, we have the regulation tank, we have the sub-main and the lateral on the field. No filters, no pump are required in order to run this system. The magic that make that whole things work and simplify that is actually the emitter itself, the dripper that within the tape. The NDRIP emitter is actually have a different or a new design to it, and we don't have the labyrinth system that you're probably familiar with, the pressurized drip. Water go directly from the inlet all the way to the outlet. There is no corner. It's a little bit wider, wider inlet, and the outlet is way larger. This system, as this concept has been proving itself in Arizona for the past 5 years, with much higher resiliency for clogging. And once again, especially when we're discussing surface water, and especially when we're discussing that midsummer. Some of the benefit that we're getting with NDRIP, once again, we're able to tap into a natural water source without any pressure to feed any filters. because the system can work with the dirty water. It's solely powered by gravity. Even if we hook up to a well, that tank over here will regulate the pressure, and the pressure that the system is carry throughout inside the field, on the field, is below 1 PSI. It's actually 0.875 PSI throughout the system. So it's a very, very low pressure system. And once again, as we already said, there is no need for any infrastructure change throughout the practice of installing NDRIP on your field. We usually will recommend if, we recommend to do some laser leveling if that field was not laser leveled in the past few years, which is anyway well-known practice in Arizona that being done anyway. The good things about applying NDRIP system to any flood system that the task of laser leveling your field can minimize to probably once every 15 to 20 years instead of once every 3 to 5 years when you flood. Some of the benefit that I mentioned earlier that we are getting in pressurized system, reduction of input, whether it's fertilizer, labor, a lot of activity on the field, which will involve machinery, cultivation, and the immediate result of utilizing the NDRIP system, of course, we're getting automatically improvement in water use efficiency. Saving water, it's something that will come in the end as an end result of efficienting your system. So by saving all those input, by taking advantage of all those input over the flood system, it will result in a, based on study, between 30 to 45% of your water application on the field. In terms of the brand itself, NDRIP, NDRIP is a bit of a unique creature here in Arizona. We are a full-scale irrigation company. Our product is being manufactured by us. We manufacturing the product. We just last year, around June, we opened our first production line in Yuma. So the product is being, the production of our tape is local. Design is being done by NDRIP team. All design. This is a low pressure design system. And in order to get the best result out of it, every field actually receiving a visit from a survey. We have a survey technician that will go out to your field and actually survey the field with an RTK. And that will be fed into the algorithm that will eventually will create the design. All installation currently are being handled by the NDRIP teams, 100% throughout the region. We don't leave our deployer and our technology currently to anybody. We will have that to be passed one at a certain point, but currently NDRIP is installing 100% of its field. After installation, we do have a great service and support team that will follow up with the grower, with the farm, for whatever time it's going to take, 12, 24, 36 months. In the end of the day, we definitely like everybody to master the technology and be able to operate it without the need of NDRIP to be around. But in order to support that aspect of the company, NDRIP is opening hubs throughout the region. Wherever we have more than a certain amount of acres, there will be an NDRIP hub with technicians and customer service that will be able to reach any grower within half a day to a day for any call we're going to get. Some of the crop rotation that we've been experiencing here in the last 5 years, obviously cotton is the biggest crop rotation that we dealt with in the past 5 years. We currently getting ready for a almost 3,300 acre of installation throughout 2024. I mean, hopefully within the next 6-7 weeks, we'll complete all of that. Some of our post experience happen they happen around the Colorado River with surface water and in central Arizona with the groundwater. So we are very accustomed to the practices and the water condition, and our system pretty much thrived throughout those experience. Once again, cotton is largely and probably right now is the largest crop that benefit out of our system. Alfalfa been a long case study for us, started last year. Was not an easy road to ride, but definitely a very beneficial one. 2024 started great for us. A lot of the lesson learned from 2023 actually came into reality, and we see more and more good result and getting more and more inquiries from clients who want to adopt the system right now. Like I said, last year was our first year with alfalfa, and it's definitely moving forward, and we see more and more great result out of the if the main challenge that we did had with alfalfa, it's the practice. Like I said, we are a new technology and we are not accustomed to all the practices on the field, which will require from NDRIP to engage with growers and learn the practices and work together in order to bring that system to an optimal condition where it can coexist with any practice you guys already taking on the field without changing none of it. Corn, another big crop for us. We've been very successful in the past 3 years working in Nebraska, which started as an old story because anybody who know Nebraska a little bit know that's the guy from Valley probably will say, what are you guys doing there? But this is a pivot land. And we've been extremely successful in Nebraska with our system. Currently, we increase our activity in Nebraska from, I believe it's 200 acre to around 1,500 acre for 2024. Some of the other crop that you can find with NDRIP in Yuma, we do have some produce, artichoke and onion that being grown under NDRIP. Very successful trial. The onion is actually both of those crops going for a second year thanks to the success the grower achieved last year, both on the yield production and of course mitigating the water challenges that they have. Fast forward to Nebraska. Nebraska, like I said, a 3 years project that we've been running in Nebraska, and actually this year, 2024, will be the 4th year. All the growers that started with us in 2021 continue, plus we have more growers. You can see the numbers, they pretty much talk for themselves in terms of irrigation, efficiency, yield production, and energy. Energy is a huge factor, and as much as we all want to grow more with less input, if we can reduce the input and say that even if we grow the same but reduce the input, that's a good start. That's why the energy factor is so important here, especially in a place like Nebraska and even central Arizona that mainly or in whole rely on groundwater. You can see some of the study that we did in Nebraska. The comparison actually were with pivots that everybody have pivots in Nebraska, flood and end-rip. So those are NDVI picture that we took toward the end of the season, and you can see the color, you can see exactly the uniformity of each field. One of the biggest advantage of end-rip over those systems, its ability to rotate back and forth to that field with a fast, efficient irrigation. So it's much easier to cover with the end-rip a large scale area and maintain that area irrigated efficiently throughout the week, the month, the season, without running late or stressing the plant. Pivot are a little bit behind that because they do have their pace and sometimes they just cover a large area. And the challenge usually will be raised in the hot days, midsummer, when we're chasing water. So once again, that's one of the study we took. You can see that graph that pretty much emphasized the difference between irrigation depth and energy cost. Pivot does show to use a little bit less input in terms of water than end-rip, but you can see the energy input is way higher, and obviously both of them are looking way greater than any flood system that we can have. Part of what we start doing here in Arizona is actually tapping into groundwater, and that's where the energy factor coming into effect. This is just a recent audit that we run on a field in Safford, and it's once again it's 160 acre, and that's audit is specifically on those 160 acre on the well they have. You can see the reduction in energy throughout the operation. The last technical part that I would like to touch is actually our decision support system, which consists of a series of sensors that will be installed in every end-rip field. Those are moisture sensors. The odd part about those sensors is they're different. They're completely different than everything been presented to the market up until today. The sensor consists of geotextile fabric that's sitting at around 10 to 12 inches below an active root zone. And that's the one you see on the left picture. And it's hooked to a tensiometer that's sitting inside, running out to a transmitter that obviously will transmit out to the cloud, and that will end up on the grower smart device, whether it's going to be the phone or a computer. You can monitor the activity like any other, I guess, technology today on a remote distance. And the benefit of that sensor is actually, if you look at the middle picture, sooner than later, though the root zone will start growing and the roots will meet that geotextile and grow into it. At that point, we actually getting readings from two elements throughout the field. We're getting reading from the soil surrounding the root zone, and we're getting reading from the root zone themselves, from the plant itself. This one. Usually on a 40-acre block, you will get 2 to 3 sensors that will integrate into one report. We do put multiple sensors, once again, just to get a much wider reading throughout the field. The sensor itself is a geotextile. The geotextile is almost a yard long, 3.5 inch wide, and 1/2 inch thick. This is the testing area. This is the reading area. So if you compare it to any other tensiometer or any other sensor that we have today in the market, the line of data that you're extracting out of the field on each report is way greater than anything else that you can get today from any other system providing live report from your field. As soon as the system will start irrigating, that's actually where the geotextile get the moisture and start reporting out on the irrigation event. In terms of missing irrigation, that sensor will dry out and start sending reports out of needs of water. Once again, both from the root zone and both from the soil surrounding that the root zone. It will help us once again, the water optimization, monitoring. We have the NDVI feature, and you do have a constant data collecting on each field that you're utilizing NDRIP. Another pretty amazing feature with that, with the sensor, we can customize that and build a nitrogen model within your device that will give you a constant reading of nitrogen movement throughout the soil, the plant, and of course the leaching factor of it. It will require a little bit of a manual work to begin with, mainly for us to receive from you your pre-season applications so we can tap it into the formula. Other than that, at that point, you're gonna start getting reading of that nitrogen out of your field. We currently have 3 hubs throughout Arizona. One of them is in Phoenix. That's where our corporate office is sitting. We do have a Yuma location where we have both the store and our production line. And in Parker, Arizona, we're hoping that by the end of 2024, we will have another hub actually facilitated in Graham County. In the past 5 years, you can see here on that map, that's pretty much the current reach of NDRIP. We've been able to reach out to, once again, Nebraska, we mentioned. California is on our 2024 scale-up plan. New Mexico, we've been working with NMSU for the past 3 years. We do have operation in Texas and Florida. This year, Nevada and Utah will join the scale-up process of NDRIP. And again, Arizona, that's our hub. This is where I will say currently 80% of our business in the US is being conducted. It's fairly new system compared to all the other technology you guys talked and heard from today. I definitely like to reach out to everybody and encourage you. There is great programs out there. One great program by the University of Arizona to actually promote technology, to go out and try to mitigate our challenges, especially the water challenge that we are all facing. And it's, yeah, my apology. I removed the slide that they talk about the university program, but I'm pretty sure everybody already familiar with that. And we are once again thankful to the state and the university to, you know, start in terms of NDRIP being part of the vendor that they pretty much working with that program. Any questions? Yes.
What do you check the longevity of the tape without flushing in any kind of pressure that we're used to? How long is it going to last?
Okay, so in terms of the tape itself, the material that the tape is actually made of, it's polyethylene, okay? Unfortunately, we all know that material can sit in the ground for 50 years and stay there without really any dent. In terms of the longevity of our system, there's a few there's a few varies that will determine that. One of them is your rotation. If your rotation, let's say, called for 3 or 4 years alfalfa, then cotton, maybe another crop, and then back to alfalfa, the question is, how often do you need to go and till the ground? Our system is shallow bury, which means it's going to be anywhere from surface level down to 4.5 inches below the surface. So any tilling activity on the field post the season, the tape going to have to be extracted first, and then you guys going to be able to go in. In terms of being in the ground and working, yeah, we can, the end can stay in the ground for 3-4 years, irrigate with dirty water, as long as, of course, we treat the system. I didn't touch that. I'll spend a few words on that, but with the right treatment, end can be in the ground as long as your rotation required. Like I said, the main challenge is groundwork because we are shallow bury. So you might gonna have to replace the tape anywhere between once every 3 years to 5 years. In cotton, we recommend to have it seasonal. You put the tape in the ground, you put the infrastructure, and you just replace the tape while you go. Most of the rotation that we've been engaged up until today actually went from cotton, tape replacement, and then 3 to 4 years alfalfa. If you can run another crop on after the alfalfa without tilling, then the system can stay intact and operate at the same time.
Planted crop like small grains and alfalfa, how are you germinating the new crop?
Okay, that's one area where we do not have much experience with germination. We just started with germinating alfalfa and Bermuda grass this year. So currently it looks amazing. At 98% of the field. On one field, it's not gonna look that amazing just because it's 98% sand. And we put the system at 38, it's a 38-inch spacing between the tape line. I will not recommend to germinate alfalfa on sandy soil with drip or with the gravity power micro irrigation. We can definitely help the crop grow and mature and yield, but germinating it's right now I have to put it as a high risk on sand. Any other soil type, the ability, because we are sitting shallow bury, the lateral movement of the water, I will take a sandy loam, for example, within 24 hours, your entire field will be blackened out. So there should be no problem to germinate, and that's where we germinate actually the alfalfa or the sandy loam. Two more points quickly. One regarding water treatment. NDRIP is a system. Every system needs treatment. So it's one of the challenges. Once again, water treatment is a must. In many cases, I will say that the biggest enemy is organic matter because that's usually the cement that causes everything to build up and clog and stay in the system. That's mainly going to attack us in open water sources, on surface water and in canal. If we can avoid canals, always better to avoid any exposure to the atmosphere. But then again, it's not always going to be possible, and water treatment protocol will have to be applied. Every system that will be installed by NDRIP will be, the grower will receive a protocol of water treatment protocol from NDRIP. On top of that, the decision support system that I presented to you in that slides actually have irrigation manual built inside by our agronomists that is based on the ETO of your crop and the region where you're growing it. We hook up to every weather station throughout the region. And that's how we build the irrigation recommendation. So anybody who using that technology the first time or using that technology after using flood for so many years, it's probably one of the best learning curve to know how to irrigate with the end drip throughout the season. Plus, like I said, we do have our team on ground and our agronomist to assist with any application throughout the first few seasons. One more important point is salinity. End drip is a shallow bury system, meaning when I said it's sitting at 2, 3, 4 inch below the surface, we watering laterally and down. So every irrigation event, we will calculate around 10% additional application within this event. And this additional 10%, well, that's what we call the leaching effect. Every irrigation, you're literally leaching the salt away from the root zone because we're sitting above and we irrigating down. So every irrigation, you're literally doing mitigating that salinity issue. I want to talk more, Dia, but I think I'm done.
Just wanted to mention that Chris would like to thank you for the nice presentation.
Thank you. Yeah.
And the other thing is the leaching fraction.
You're not gonna get
required for
presentation done.
it's required
Yeah.
with irrigation for any system that we have, whether you're irrigating by flood irrigation or using pressurized system, you have to apply a little bit more. Usual number is about 50%, but to know the exact number, you do analysis with the soil salinity. And for the water salinity, and they're very simple equation, we need the actual number needed for it. So, we're a little bit early. If you have any more questions for Yuri? Nothing? Okay. Where is Yuri? He left?
No, right here.
I didn't see him. Oh, so one question from me about the cost of tape per acre. Yeah, if you would like to change the tape, for example, how much would you guys charge him if you install it, and how much would you charge him just for the tape and they install it?
So currently, as I mentioned, if you're all technical aspects of the system, we will run the installation ourselves. And cost to replace tape right now based on 40
Yeah.
We'll go around $600 a day.
600. Good. Okay. So our next speaker is Eric from Rubicon. Rubicon Company, and the title for his presentation is Automated Gates for Flood Irrigation. And here is Eric. Video. Much time now.
Good afternoon. One of the best for last, I guess. 30 minutes, okay. So my name is Eric Rothberg. I'm the sales manager for North America for Rubicon. I've been with Rubicon for about 4.5 years now. And we're going to talk about Rubicon in general, but then we're going to fall into or specialize on the side of high precision flood irrigation with automation. How do we do that and how do we get there? So Rubicon is an Australian company. We've been in Australia since the 90s. We've been here in the US since the 95, 96. The core of our business has been automation of irrigation canals for irrigation districts. So we have a large amount of systems. Basically, what we do is we sell gates that are measuring flow, maintaining level on the canals. We have telemetry. We also have software. So lots of the irrigation districts here in the country, IID as an example, has 300 of our systems. So we're growing very fast here in the US. And it's all about conserving water. And instead of having people running around chasing gates, opening gates, we're doing that with automation. So as I mentioned, we're based in Australia. We have over 200 customers worldwide. Most irrigation system districts here in the US, the large ones, are working with us. We have over 35,000 systems installed. And brief overview of where we are, what we have installed. Here in the US, we have actually that number is now 3,500. So we are assembling those systems now in Modesto, California. So we're taking our gates and software and telemetry and everything else, and we're assembling the systems in Modesto as well. Going quickly through the key facts. One of the big problems that we see worldwide, which is a great opportunity for people like Rubicon who are automating canal systems and water distribution systems, is on an average, only 37% of the water that's released from a dam or a major river or a lake actually gets to the plant for consumptive use. So you have a huge loss, generally speaking, of water through the canal system. Some of it's evaporation, not much. A lot of it's leakage, a lot of it's spillage, a lot of it's unaccounted use of water. So there's an enormous amount of water that can be saved if you automate and make the delivery systems more efficient. And this explains a little bit how you see some of those losses. Those are numbers published, by the way, by the World Bank. And so you can see that only 37% on average actually gets to the plant. So there's a lot of losses throughout the entire system. And the major part of our business has been automation of check structures and canals and so forth, all the way up to the farm delivery point. We see that worldwide, one of the big things overall with the technology, with drip, micro sprinklers, satellite imagery, moisture sensors, everything else, we see that the irrigation technology in general on the farm side has evolved tremendously. But the distribution side, which is having water in the canals at the right time when you need it, that's where there is a big opportunity for growth and for making things more efficient. What we're preaching as a company is changing from a model of scheduled delivery. So, Mr. Farmer, you have water in your canal next week. Well, it rained a couple of days ago. Well, that's when you're going to get your water. Take it or leave it. To a model where you have on demand. So in Australia, for example, we have very large systems with 15,000 farmers automated with thousands of miles of canals and laterals and ditches and gates, where the farmer orders water within 2 hours through his cell phone, and he can also cancel that order right away. So what we're trying to say is we're trying to change the paradigm to going from scheduled delivery to on-demand delivery. But to do on-demand delivery, you need to have automation. Automation is very important for that because you can't have enough guys running around, closing, measuring, and being efficient on a system in general. So that's where we come. That's where we specialize, is really on automation of the delivery system to the farm. I won't go through many details on each slide, but at the cream of what you're trying to do, what we're trying to do is really put water on the plant when it needs it. not when you have it available in your ditch or your canal or your lateral. When the water needs plant, that's when we should give it water. And there's enough technology out there, enough experience to do that. But a lot of districts, because they don't have automation, the canals are not full. You have to wait for your day or your week to irrigate. So what we're trying to do is obviously automate all that. And we have a lot of very large customers here in the States, like Turlock Irrigation District, Imperial, Oakdale, working with large customers in Nebraska, for example, and other areas. We're really putting a lot of technology and automation in their canal structures. So we can automate check structures. They're all solar powered gates. There's telemetry. They're operating in sync. They're maintaining levels. They're measuring very precisely the flow. So our gates can measure down to 2.5% the flow that's going through a gate. A lot of times people are using gates, measuring orifice equation, which is at best 10% certainty of data. We can go down to 2.5. All the gates have built-in telemetry and upstream and downstream level sensors. So if you measure, for example, in your farm, you open a gate and you see that it's open for 4 inches or whatever, you calculate an amount. The moment that ditch varies in flow, that flow is no longer correct. So our gates are continuously adjusting to maintain that flow that you need in a system and continuously measuring the flow and adjusting to what's happening in the canals and the laterals and the ditches. So what we're trying to do is obviously, we're talking about automation from catchment to the crop and what can be done throughout this cycle to make the system more efficient. In the most advanced area that we work on, we have something called TCC, Total Canal Control. So imagine an irrigation district with thousands of laterals, thousands of farmer gates. All of the gates are talking to each other with our software. And basically what's happening is farmer A opens his gate, he's irrigating, the canal starts to adjust level, that gate tells the next gate and so forth. And the whole system is adapting in real time to what's happening. Now, doesn't mean that everybody's going to get water at the same time because no one has an unlimited amount of water. But what it means is that you're going to measure and you're going to know exactly how much each farm is taking, and you're going to be able to provide the farmer with exactly the flow they need for that application to be efficient. There's many different types of systems and gates that we build. Again, all of them have built-in telemetry. All of them are solar powered. All of them measure and control flow for the most part. Small ones, large ones. And I won't go through explaining all of the technology, but bottom line is we're basically measuring flow in canals and laterals and ditches and automating those gates. So those gates can be open through your cell phone. You could be in China. You could open a gate. You can see how much water is going through it and how much is going into the system. It's all with telemetry. So if, let's say, a tire gets stuck in there or a bush or something happens, it sends you an alarm saying, hey, something's wrong. So a lot of savings on the labor side. So a lot of districts that have people running around on pickup trucks or guys running around and open this, close that, this is eliminated, and they can do more important things as opposed to chasing water when the system is automated. In terms of the on-farm side, 2 of the most used systems are the slip meter and the picometer. And we have different sizes, different capabilities of flow, different heights. But when you look at a system that's installed, what we do we have 2 types of technology, the overshot gates and the undershot gates. The undershot gates are using velocity profile in order to measure how much water is coming through each gate. And if the gate is not totally submerged, the sensors detect that there's no water there and it ignores the readings of those sensors at the top. So the gate's continuously adjusting to what you want. So if you say, I want this gate to be delivering 10 CFS, no matter what happens in the canal or the ditch, the gate's going to be delivering 10 CFS. Or if you said, I want my ditch all the way down 2 miles down to have a level of 3 feet, we can control that level as well. So you can operate on level, you can operate on flow, and you can also operate in a combination of those. Some examples, all the gates are designed to install where you currently have your gates or, small modifications. They're all lowered on a frame and they can then be taken out for maintenance if need be. And you have a picometers, for example, small turnouts. The picometer is a gate that goes up to about 12 CFS. We have different sizes, different heights, but essentially is a totally contained system. Just for price comparison, right? So a picometer is going to be about $10,000-$12,000. Obviously, it's going to be costing more than a water main gate or anything else. That's going to be maybe $1,000, $2,000. But this is a different vein. This is complete telemetry. This is sending you the flow that's going through it instantaneously. It's sending you all kinds of accumulation of flow. There's 160 data points that can be sent from the gate back to your system on the cloud or on your server. If the solar panels are dirty, they're not charging, it sends you a text. If something is stuck, it sends you a text. Each gate has a pedestal, and inside of the pedestal is where you have the operation, the computing capability, which means that the gates are communicating via cellular or via radio on the irrigation districts or on the farm. But if the system were to all of a sudden collapse, the gate remembers the last instruction it was told to do. So if it was told work at 10 CFS, that's what it's going to do until somebody comes and reestablish connection, or somebody opens the gate, puts their password in there, and then says, I want to make a change here. So it's measuring very precisely, and then it's keeping track of how much water you used during the season. And again, we have different sizes and different models for different turnouts. Again, won't go through this, but in essence, what happens is the system is talking to each other throughout the system itself and adapting to the necessities or to things that are happening in real time. So lots of experience on the automation of canals, lots of experience on the automation with the software, telemetry, and that type of thing for irrigation districts. The next step for us was to go to the on-farm side. And what we've done on the on-farm side was come up with a system where we can automate flood irrigation. Now, we're not saying here, don't use drip, don't use sprinklers, don't use mechanized. I'm not saying any of that. What we're saying is if you currently have flood irrigation and you're saying, how do I get this more efficient? We have a system that can take it from 35 to 40% efficiency or 50% efficiency, all the way up to 85 plus efficiency. So flood irrigation in traditional ways it has been applied is considered somewhat inefficient. It has its place, but we can take it with automation and instrumentation. We can take flood irrigation to very high levels of efficiency. And that's a combination of software. It's a combination of telemetry. So we have developed a system called LoRa. We have used LoRa system inside of our gates. So the gates in our inside of a farm, for example, are going to be communicating to each other and to the portal through radio communication, which is very fast and uses very little energy. There's a little solar panel and the system inside. This is an example of a gate that we design. We have different sizes, and you'll see a video of this in a minute. So these gates are basically designed, if you have your main canal here, let's say this is the district canal going here, and you have your laterals. Our gate is basically going to be automated, and when it's time to run the irrigation program that you put in there, it's going to open up automatically, it's going to irrigate, and then it's going to close. There's a sensor that detects how far the water traveled, so you don't have spill at the end, and it tells the gate how long to operate, and I'll show you some information on that. So here's an example. We have lots of systems in Australia. We have some systems now here, and the system I'm going to show you is in Palo Verde Irrigation District. We do have some in Imperial Valley as well. A lot of them with alfalfa, but also with cotton. So what we're trying to say here is that, again, if you have surface water available and you're irrigating with surface water, which is the great majority of people and in many places, if your soil has the right conditions, you can make surface irrigation or flood irrigation. We don't like calling it flood irrigation, much more efficient than it currently is, lower cost than using pressurized systems, and no filtration, same water you're using, and it has a dual purpose. So in summer, you can irrigate with high efficiency. In winter, if you need to put water back in the ground, like in California in the Central Valley, the same system can be used. And it's all measuring very precisely how much water you sent into each of the fields. For those people that have the alfalfa valves, that you have a lot of those down in the Central Valley, we can automate those as well. And they're going to operate automatically, opening and closing based on what's happening in the field. Let me just show you. So this is the big difference on our system with traditional flood irrigation. If your gate that you have opening for a parcel of 10 acres, as an example, is currently delivering 2 or 3 CFS, our gate's going to deliver 4 or 5 or 6 CFS. So we're really increasing the amount of water per unit of land, increasing it to where you're irrigating much more quickly. So let's say traditionally the guy comes there, opens this gate, goes back someplace else, do something else, goes to sleep, comes up, wakes up, whatever he's doing, and that takes 8 or 10 hours to get to the end. Our system takes about half that time, which means we're putting a lot of water very quickly. It's not causing erosion, but it's going just where the root zone is. We're not putting water below the root zone. That's a different type of application if you're trying to replenish water in the ground. By doing that, we're applying much less water and giving the plant the water that it needs when it needs, avoiding a lot of the flood systems you have in the beginning of the field or the end of the field. You'll see those areas with saturation of water, the crops are yellow. It's too much water. Generally speaking, in every type of irrigation, but mostly in flood, we're applying way more water than is needed. And the problem is the speed. If it's traveling slow, you have much more chance for it to infiltrate below the root zone. That's what we're trying to avoid. We're trying to make the water travel relatively fast through the system. Let me show you a couple more things. So we have an irrigation program. You put it in there. You know what gate is open where, when, how much water is going through the gate. This is some more pictures. The smart front sensor. So this device, it's communicating via LoRa. This device will be installed, and it's a device that's installed. When you harvest, you can take it out. It's basically a pipe, and it's reading how fast the water is going from A to B. So if there's 100 foot, and if your parcel is 100 foot, and it got to 50 foot in 2 hours, that sends a signal back to the gate, and it says, hey, it took 2 hours to get here because today it took 2 hours. Next week, it might take 1.5 because there's still more moisture in the soil. It all depends on how much moisture is in the soil. So this is telling the gate when to close, and it's telling the gate, once it closes, it tells the next gate, your turn to open. So The gates are opening automatically, and they're all sensing how much water was in the field, and you have zero spill at the end, which is the objective. Again, our system is agnostic, so we can talk to different type of moisture sensors. We can talk to different types of sensors in general. We have our own weather station that we can put in our gates as well, but it will talk to other gates as well, to other systems. And so it's an open system in the sense that we're every month we're putting more systems that can talk to our system. So basically what you have, either you have a gate or you have one of these pedestals in the middle of the farm, and all the gates with the LoRa system are talking to this system. This system is talking to the internet. So the farmer is in his house, for example, or his cell phone, wherever he is. That system is sending all the information from all the outer gates. And he can on the fly change his irrigation if he wants. So I need less water now, or I need more, or I need to make adjustments. And if anything goes wrong in the system, it's then sending you alarms and signals saying, hey, this gate's not operating well, something's not right. You might have someone check it out. Again, all of the system is logging all the data on the cloud or the server. And you can go back and you can see how much water was applied in each parcel and when. So obviously we have to talk a little bit about system maintenance. And because there's no pumping, because there's no filtration, because there's no tape, there's none of that stuff, just gates that are opening and closing automatically to irrigate. The maintenance would be occasionally clean these solar panels if they're very dirty because they're not recharging the battery. The batteries that are in there are designed to last 2 or 3 years inside of each of those nodes, so very little maintenance. If you need to clean sensors on the gates, a lot of times the district is going to be doing the cleaning of that sensor if need be, once a year, once every 2 years. It's not typically speaking, the sensors are designed to operate clean. And we have systems operating since 2012 here in the US and very little maintenance. Now, every system that gets installed has a tune-up period, and you're tuning and learning about the system. And over time, the system is learning to become more efficient and apply water more efficiently. Let's put that video. This video is in a farm called Fondo Monte in Palo Verde, big outfit. And before you started, I'll just explain something really quick. This was 80 acres installed, and they're about to give us an order for 3,000 acres now. One of the interesting things here, you'll see how it's operating, but this field is using 50% less water than traditional flood they were using before. And he's getting 1 to 2 tons more of alfalfa than he was getting with traditional flood. So less water, more production, which is a lot of times counterintuitive. Like, why is he producing more with less? Well, you're giving the plant the water it needs when it needs it. You're not over flooding the end of the field or the beginning of the field. But you still have a system that can wash the salts if you need to. You still have a system that can control gophers or whatever if you need to. So it's the best of both worlds. One of the problems we see in the Central Valley of California is that with technology, everybody converted from flood, which is inefficient, to pumping and dripping and all that. Because everybody did that, they're not replenishing the groundwater. So the groundwater is overpumped. Now the districts are coming back. Hey, Mr. Farmer, don't take out your flood irrigation. I know you want to put drip or something else, but still keep your flood irrigation because we want to flood and replenish water in winter. So this system can be programmed so it does both things. Let's play. So can you freeze it there for a sec? Okay, go back. Right there. All right, so this picture here, what you see is that canal there is a Palo Verdes canal. This over here is our gate. Now, traditionally, the idea is that the irrigation district is going to operate our gate on their canal. And this, because it was a test and a new thing for them, the district said, hey, I'd rather not put your gate there. So we put it in the farmer's side. But what's going to happen is with the automation, the farmer's going to call the district and say, hey, I want 20 CFS coming down this ditch for 5 hours. And that's what's going to happen. The gate's going to open at 7 in the morning, close at whatever time after the system is done. And then it tells the next gate to open, and it's all automated. In this case, this is a slip meter. So if you see that gate that's in the river, in the canal, there's a guy that comes there early in the morning, open that gate by hand, puts a little piece of paper. I opened at 20 inches, and at 8 in the morning, he comes back with his truck. He keeps looking at the canal. The moment this canal here varies in height, that's no longer 10 CFS. That changed. So the farmer is really not still getting billed for 10 CFS, but he might be getting 8 CFS for 5 hours. So the beauty of these gates is that they're measuring everything and they're adapting to the level in the canal. So if the level goes down, which means your head pressure goes down, the gate opens more. Hey, I need more. And it's always doing that, continuously operating to maintain that. Thanks, Larry. Again, this is 80 acres. You can see the gates on the sides, and basically opens 1 or 2 at a time and irrigates. It's done, closes, next one comes online, and that's how it operates. So you can see that we're putting quite a good volume of water. So instead of having many little small gates like usually you have in your farm, we would close some of those and have bigger gates. You notice the one on the right is irrigating, the one on the left is not. Those are all timed, and there's all those gates are talking to each other. And the sensors would then detect the water before it starts spilling on the other side. So these guys here are saving 50% of the water just because of automation and the way we apply the water. Could this be done manually? Potentially, if you have 300 guys running around the field all day long, closing, opening, measuring, it's impossible because of labor cost, right? And computation of data. So the system is actually adjusting in real time to what's happening. This field on the other side here is a manual field, and you can see how many gates he has. The traditional system is a gate here, there's a gate there, there's another gate. Basically eliminate those gates, and we create one big gate in more area. So we might need to divide the plots a little differently, but it's all about speed of water, volume of water going through an area and not allowing it to go below the root zone because it's doing you no good. Unless you're trying to flood it to volts. That's another application. So this is my presentation. I'm not the specialist. Peter Moeller is our guy. He's in Italy this week on a conference. So he asked me, I'm more focused on the canal side. But there's some information, my card's there, if anybody's interested. Any questions? Yes. Yeah. Is there an example, or how are the gates connected, or how do the gates open? That's the question? Or how do you avoid overflow? Okay. So the gates are talking to each other, right? So when one gate starts closing, it's my turn to close. A signal is sent to the other gate, it's my turn to open. And they're all connected to each other, so you know that you're not. The system at the heading is also measuring the flow. So if the system says, I need to send 10 CFS down this, all of a sudden 2 gates are open. Hey, I'm sending 20 CFS, something's not right. Sends a text back to the operator, hey, something's not working well. So it's communicating. When it's working, it's communicating, they're telling you it's green, it's all well. If things are not working, it will also send you a text. Now, just to be clear, we don't say eliminate completely people. We're not saying that. What we're saying is that people can be used to do better things, more important things than opening and closing gates and doing that type of thing. But that's how you achieve the efficiency. The basins are level, and sometimes they have a little bit of a maybe 0.5%. So it's designed to work with the current systems that you have now. So the current fields, we might design a field. If it's maybe you have a field that's 7.5 acres, we might say this should probably be 10 acres. We'll put a gate here, another 10 acre, another 10 acre. The cost of this technology is $1,000 to $2,000 an acre. It is and can be cheaper than drip or pumping or any other type of technology in that sense, but it has its place. If you're using drip in a very sandy soil, well, just use drip. It's perfect for that. Or if you have hills. So what we're saying here is if you're already operating flood irrigation, we can come in and take a look at your system and design something for you to try or for you to go see how more efficient you can be with automation.
Our next speaker is Jesse from RDO Water, and his presentation is General Irrigation Maintenance Overview. So we are ready. Okay.
Thank you very much. Oh, hello, everybody. My name is Jesse. I'm with RDO Water. I'm the regional sales manager for RDO Water for the Desert Southwest. I want to thank Dia for the invitation. Thanks for letting us talk a little bit about what we do, about our company, and participate with the subject as well of maintenance. My title was Agricultural Irrigation System Maintenance Overview. So it's gonna be a quick overview of maintenance on irrigation systems, and I'm gonna try to keep it brief. So let's get right into it. I cannot start speaking about RDO Water without mentioning that we are part of the RDO equipment family. Founded in 1968, I believe everybody at least heard about RDO at some point. We have an agriculture department, construction department, Vermeer, integrated controls, and of course the irrigation portion of it. We brag ourselves about our core values, something that it's a daily work in progress, of course, but that's our main goals: to partner up with employees, to build customers for life, create opportunities, And my favorite one, and actually the hardest part, is that we do what we say, right? And we play to win. So we have presence in the domestic locations all over the United States. The region for the irrigation portion is the desert Southwest. We call it the coast and the desert, with the stores in Raleigh, Yuma, Salinas, Oxnard area, Watsonville. And we have some international locations as well for the equipment side of the operation. Right, so that's a little bit of for RDO Equipment family and how we come in with the irrigation portion. Now, instead of talking about RDO water and how good we are, and we're sticking to the good old sprinklers and good old drip. But I was doing a little bit of research. First year that I started with the company was back in 2012, and I just started asking questions about what we do and why should the customer pick us, instead of other companies. We have a lot of good competitors out there. So after my research started asking questions, there's a few things that they're worth it to share. So we've been around for a little bit more than 42 years, before RDO Water being part of RDO Equipment as a water tech or an ag supply. And we have a lot of experience in the desert Southwest. We have a record of installing over 100,000 acres of SDI systems, in these past years within the whole United States, not only in the desert, Southwest. We offer comprehensive training, assessment, diagnosis, evaluation services for irrigation equipment, and automation, which right now is something that's state of the art. We partnered up with a few major brands out there, and we have the capacity to run more than 15,000 acres, which is worth of sprinkler irrigation, along with a complete system of booster pumps, sprinklers, aluminum, Certaset, and all that fun stuff. RDO Water takes pride in its core values, like mentioned before: vision and industry mission. The forefront of these principles, it's we do what we say. Now, our services, we offer part sales, we offer rentals, irrigation systems and equipment rentals. Like I said, aluminum pipe, Certaset pipe, booster pumps, drip units for filtration. We install subsurface drip systems, as mentioned before, with a little bit over than 100,000 acres we've done in the past. And we offer the services by, separate injection, extraction, connections, whatever you as farm might need, right? We also offer customer sprinkling, go in and out, rent the pipe, install it, and just as an extra service, just not renting the pipe. We do custom maintenance, and we have some service pros I'm gonna talk about a little bit more after. We of course offer the turnkey hydraulic design, starting point with installation, part sales, rental, whatever you guys need. And well, that's a pre-integrated part of the turnkey projects. So to talk about maintenance, I try to find there's a bunch of concepts out there for maintenance, and I like this one because it's related to system maintenance. It reads like it's a process of keeping a company's technology, infrastructure, equipment, and software running smoothly and efficiently. It is a crucial aspect of running a business, as ensures the smooth functioning of all the systems that the company depends on to carry out its operations. Now, like I said, I'll try to be a quick overview of the irrigation or aggregation components. I chose a few, and the same way I chose just a general ideas of maintenance. I found more than 20 type of maintenance out there. There's two major ones: are preventive maintenance, corrective maintenance. I think we already mentioned some stuff related to this, but just to keep it simple, under the preventive maintenance, predetermined maintenance, pretty self-explanatory, condition-based, and predictive are part of the preventing, the PMI, right? Corrective maintenance, reactive, something happens, then we fixed it, right? So, like I said, just an overview. We can discuss this more further, but jumping right to the components of our irrigation system, I chose
two types of irrigation systems and one component. Filtration is the first one. So the importance of filtration system in agriculture irrigation, whether it's screens, disc filters, media filters, these systems play a critical role in preventing clogging and maintaining water quality. Regular maintenance is key. It's a sure optimal performance. And I know, in fact, this morning we discussed some drip maintenance for other companies. So neglecting filtration system maintenance can lead to decreased flow rates, reduced system efficiency, and potential crop damage. And my favorite part of telling the customer you need to pay for maintenance is it's going to be more expensive, right? If you don't do it, it's going to be more expensive at the end of the day. So, that's the right one. The first step, all these processes, like for example, in these component, which is filtration, is to try to find the right one, right? The right type of filtration for my system. There's a few out there. Chose these sand separator, screens, medias, discs. They're different for they're sort of for different applications. They have advantages, they have disadvantages. It's just important that you chose the right one for your type of application. That's the first step, right? And then, after your system is running, you need to have a program, you need to have a maintenance program, and whichever way efficiency is calculated cannot be maintained without a proper and regular maintenance of the filter. Without it, you will most likely encounter problems and the filter will fail to protect the irrigation system a year. You can do weekly maintenances, you can do daily checkouts, check pressure differentials, you can do maintenance at the end of the irrigation season, you can do maintenance at the start of the irrigation season. There's a lot of options out there, companies offering, different programs of maintenance that is just important to take a look at it. The way that you require to be that, or to provide that maintenance, right? Drip tape. After filtration system, you got your filters. Now you decided to go with drip tape. Well, drip irrigation has revolutionized water efficiency in agriculture, but the proper maintenance is key to the success of it. So the drip requires careful attention to prevent clogging. Of course, we already know that. Ensure uniform water distribution. Regular flushing and inspection of the meters are essential. Additionally, the use of chemicals such acid solutions, chlorine or hydrogen peroxide can help prevent biofiltration, algae growth within the system. However, it's crucial that you use these chemicals, very carefully and consider environmental checks. The first step you cannot talk or discuss drip irrigation without considering that you need to have a professional hydraulic design. That's the first step. And have a proper installation and of course a maintenance program. For optimal performance, drip irrigation system requires simple routine checkups. If regular maintenance is not performed, the risk of damage to the irrigation system increases. And again, it's going to be more expensive. At the end of the day, you're going to have crop damages and a bunch of things that could happen. There's many programs out there also for drip irrigation. Most of them, they talk about weekly maintenance, monthly maintenance, or just, a few times per season maintenance. Depend on your crop, depend what you're doing. You can check small things as check the water reaches the end of the line, the spot, checking the drippers, check the pressure differential, PDs and filters and the tape. Check the flow rate, the pressure in each irrigation shift. For monthly maintenance, manual flushing, flushing drip lines, and of course, specifics or required interval between flushing. It's going to depend on whatever water quality is. And if you decide to do just a few seasons, a few times per season, well, there's other things that you can approach. Another one is a type of irrigation, of course, is sprinkler irrigation. And sometimes I have some customers or coworkers thinking, well, sprinklers, they don't need much of maintenance. Well, they do. They need attention as well. Sprinklers irrigation system are widely used because their versatility and coverage area, right? They too require regular maintenance to operate efficiently. This includes inspecting and cleaning nozzles, checking for leaks, ensuring proper alignment, operation of sprinkler heads, etc. Properly maintaining sprinkler system can minimize water waste, reduce energy consumption, and optimize your crop yield. I think we agree to that. RDO water and maintenance. So we do have what we call a 20 hours program. Every time we install, we have a system installation. We offer or we should offer these a training program to our customers. Either we provide ourselves kind of a training, one-on-one training with the foremans or whoever is interested in it, and filtration and drip maintenance, sprinkler maintenance, whatever the case is for the installation we do, or upon request, if it's a system that we didn't install, but also we can provide some kind of assessment on training, we do that as well. Ag irrigation maintenance, I strongly believe, is just not a task. It's a responsibility. By implementing proper maintenance techniques and staying proactive, we can preserve water sources, optimize crop production, and safeguard the future of agriculture. Thank you for your attention, and let's work together to cultivate more sustainable future like we're going to do. Thank you.
Any question?
Start as soon as possible. People are leaving. This is the last one. So my presentation is very short and I'll finish very quickly so we can go home. It's about enhancing irrigation efficiency through advanced soil moisture sensors. This is a project funded by the Water Irrigation Efficiency Program. As it was mentioned earlier, this program would provide $1,500 per acre for farmers so they can put a new system. I mean, more efficient systems than flood, like pressurized drip, center pivot, gravity drip, or any systems that you would like as a farmer. They would install it and give you only $1,500 and you are supposed to provide the rest. So that program as well supports research. So I submitted a proposal to install 3 sensors per farm. So I am trying to distribute in 10 farms across the state of Arizona where we put 3 sensors per farm, and we'll get the data, we'll give access to the farmer so he can see the soil moisture inside his soil profile. At the same time we will analyze it and would help him with his irrigation management if he would like to do that. So the start of the project was in April 1st, and that project is supposed to last for 3 years. So we will have the sensor. It's called Syntec, from Syntec companies they presented earlier, and we'll have them in a farmer's field for 3 years. Okay, if he changes a crop, we'll go there, uninstall and install again. So why do we need something like that? We have water issue. We don't have the same amount of water that we had before. So there is also growing interest on optimizing irrigation efficiency because of that. So the goals are to introduce and implement advanced soil moisture sensors like Syntec in growers' fields. Also to monitor and manage soil moisture content and soil salinity, because the soil moisture sensor doesn't only do the soil moisture, but also it would monitor salinity in the plant root zone, and also it would monitor soil temperature. So final goal is to improve irrigation scheduling and save water. As I said, we have 30 Syntec sensors. They have multiple sensors. They have a sensor every 4 inches. So it's 4 feet. So we have 48 sensors in that probe. where we're going to install this inside the soil. And they would deliver real-time soil moisture content, salinity, right? And then give you like better understanding of the soil moisture content and how it moves into the soil when you need to irrigate and all this information. Also, the company, as I understand, they provide irrigation scheduling service, like their application on your phone or on your computer will give you guidance on when to irrigate and how much you need to irrigate. And part of what we are going to do is to do calibration, right? Because sensor, when you put it in a different soil, sometimes it's not very accurate. However, they did some calibration equations. They have it. It's something built in on their system, but we will help by collecting more soil moisture samples from the soil when we install, and we'll try to help with the calibration for that sensor. And so the data will be collected from different fields that's across the state of Arizona that would help the farmer with decision about, as I said, when to irrigate and how much to irrigate. And they would understand the nature of their soil, how the water moves quickly inside the root zone. And we'll be able to help the farmers, understand this data, whether it's through us, like the team at the University of Arizona, or by inviting people from the company by Zoom, by phone, or they may come in person if they are available to help the farmers with that, like how to utilize their sensor and how to read the data that's available from that sensor. And what we expect is that we'll have tons of information about different soil types, different crops, and different locations. The data will be presented in events like this, in workshops, in field visits, and in extension publications. We expect that we have about one workshop in the first year to explain about the sensor, how it's being used, and stuff like that. And then we'd have about 2 in the following years. Maybe part of it is to give some training about the user sensors. The other one is to, also to teach them how to use it and how to utilize it. And hopefully they will adapt this type of technology after the 3 years. So in the following years, we'll use all this data, we'll do analysis, we'll compare this data to the data that we collect from something called OpenET. So OpenET is satellite-based calculation of crop water use. They provide it for bigger areas. So we'll prepare, we'll be able to get the data and analyze it, and we'll be able to compare it to the OpenET data and see how it's different. Does it agree with that type of data that's provided for free, or not? So what we expect is that people would have, better understanding of the soil water content and how water moves inside the soil through the different sensors in the soil profile. We expect to save some water by using this type of sensors. We expect to reduce labor. And, as I said, we'll have better understanding of this sensor and the OpenET data. Okay. So these are farmers already applied for the programs. We have more than now. I think we are about 15 farmers interested in this sensor. We are just looking at the different farms. We are doing visits to the farms because, as I said, we need to have different fields. We cannot put them in the same soil, in the same area. So we're trying to get variability in the soil and in the crops. So we are in the process of choosing which 10 farms exactly, but we have lots of interest in that program. This is a location before we updated. We have more people in that area, right? And more in the south. So we are trying to choose, as I said, now we have for example, in that area, we have 4 farms interested, but we cannot have, 4 people using the same sensor in the same area. This is a sensor, this is, I believe, the 4 feet sensor where you, don't make that hole. You dig a small hole. I think it's 1 inch. They have their own installation tool when we are supposed to use it, which would, I think you connect it to a drill and you try to dig a hole like 4 feet and you put the sensor without disturbing the soil. And then, right away, once you connect, it will give you data, right? So again, to summarize it, we have about 12 sensors, one every 4 inch. And we have continuous soil moisture measurements. It gives data, I think, every 15 minutes. And you can set it, I think, to 30 minutes or whatever you prefer. It measures moisture content, also temperature and EC at different depths. And it's pre-calibrated, but we can do like extra calibration, like we'll collect more data to try to see how that is accurate. And undisturbed installation, so you don't have to, just a 2-inch hole, and it's very simple. Sometimes when you find it's hard to dig, we put a little bit of moisture and it will help a lot. And there's no slurry needed like other sensors, which is good. And the sensor is completely inside the soil, so it doesn't show anything. What shows on top of the soil is just the head that sends the data to clouds, right? But the sensor itself is below. So the top part, you can remove it, put it on the bed, which we did last week, for example, or this week, I'm sorry. And for the tractor to come and do the cultivation, then you can put it back and continue. But the sensor itself is below the surface. And we are hoping this, type of sensor will last for a long time. And this is an installation kit I was talking about. They sell it with the sensor. Okay, there are different types. Like this one, for example, would be sticking out like that. I don't like to have something like that. But in general, they give you different options. This is what I was talking about. This part, you can remove, right? And put in the bed if you'd like to service the field, like do cultivation or anything like that. If not, it's very short, doesn't show. So, and you have to have a subscription, right? Where for the internet and for you to get the data on your phone or your computer. It's a nice thing about it, as I said, it's a real-time monitoring. So, you can, whenever you have an issue in your field, you can have information about it right away. They'll provide the data in the form of graphs and tables, whatever you prefer. You can access it remotely from your phone, right? They have a system called the Irrigation Live. I'm sure you listened to the presentation before us, before lunch. This is a type of, figures you can see, like soil moisture content on different depths. And they have another index they created based on all the soil layers to give an indication where you are, whether you need to irrigate or not, right? And these are, to show you when you irrigated, also can give you an indication if your root depth based on the soil moisture content. When you see activities in certain layer, you would know that you reached that layer with your roots. Okay. So to give you soil moisture content, root activities, right? Depths of irrigation, rooting front, right? And you can change, the way you would like to see it with the company, contact them and say, you know what, this is all what I would like to see. I don't want all this. I would like to see, let's say, the depths per layer in a form of table or whatever. So you can, I think you can discuss it with them and, customize it so it would be suitable for you. Okay. And that's it. So the program, I didn't decide, I didn't finalize the farms yet. If someone is interested, let me know and I can add you to the list. Now we are looking for more farms towards the north, right? And east, west, we have enough on the south, right, of the state of Arizona. We'll come service it if needed. We'll provide technical support. The company is willing to do the same. They didn't sell us a sensor and they left. They are willing to help us all the 3 years and the farmers. So whenever they are needed, you'll come and present and talk about any issue you may have. For us, we'll come install. And if you are done with that crop, we'll come and install and help you install again with the next crop. So if you are interested, contact me. And I have my card with me if you'd like to come and take it, or you can have information about my email on the website for Maricopa Agriculture Center. So thank you so much. And so I'm done with the presentation. I just wanted to mention that I'm very impressed with people coming today, like companies and, farmers and, technicians and people working in research. This indicates that everyone here is, we are willing to do something to save water, right? So I'm sure the companies are not here to just to talk about their product and sell it, but just to inform everyone that we are here, we're willing to help. Our systems can save water compared to flood, of course. I know some people did great with flood, but in general, I don't think they would approach the 90 or above that we can get from pressurized drip or sprinkler system, so we have lots of options. And it doesn't mean we're competing with each other. We're just providing different options. Like, for example, in drip, if you don't have energy, what can you do? This is a system that's available at a cheaper price and can work without, energy. Rubicon is the same way. If you insist on using, flood irrigation, this is a good option for you. So, and also I don't want to forget irrigation management. It's an important part. So it's not only the system, but also you would like to manage it properly, because someone may have drip system or sprinkler or gravity drip, but he applies a lot, right? So he applies big amount of water. So you need to manage irrigation, know how much to irrigate and when to apply this irrigation, right? And so this is one. And the other thing is the maintenance. This is a topic of our workshop. It's very important. You cannot have a system without expecting that it would need maintenance. If you talk about drip, for example, pressurized, yes, you need to apply acid, you need to maintain it. Same thing for end drip, same thing for sprinkler system, Rubicon gates. If you have an issue, you cannot blame the company. You need to work with them and try to follow a special protocol that they would provide to you, and you have to use it, right? If you need to apply acid every certain time, you need to apply acid. If they tell you that the system shouldn't be used only twice a week, for example, the drip, otherwise, you will have deposits and you will have clogging. For the drip, the advantage of drip, you will get it when you use the system continuously a few times a week, let's say 4 or 5 times, right? So you cannot focus your irrigation in 2 days and expect the system will last. So we need to work with the companies and follow protocols. And sorry, I forgot about the mobile drip, right? This is another option. And to be honest, I'm very impressed with what I have seen today. Right? I know the company for a while, and I see big difference from the beginning to now. And everyone here, all the companies are doing their best to improve, whether it's, like this mobile drip, Dragon Line, or, Valley Irrigation, or NataFem, or N-Drip, or Rubicon. They are all working. I've heard about all these systems a while ago, and I've seen how the change they did to improve their system. So please work with them, follow protocols, and we'll see you in next workshop. Thank you. Just wanted to thank also the people who attended by Zoom. Thank you so much for your attendance. Thank you.